null pointer. So we set up an array here and we store that in a location that is pointed to by the pointer to character here. And we say whatever target we are looking for. In this case, we want to find this t here. We are going to set up another character array that is going to store our result. The result is really going to be a pointer, which is going to be pointing to something valid if we find the target. And it's going to be null pointer if we didn't find the target. And we set up another variable which is going to store how many iterations we did. We should really make this an unsigned integer or size t, so let's make that here. And we're going to loop here. So the first time we loop in here, we're going to call this guy. We're going to say, I want to find a t in result here. And the result is going to be pointing to this thing here because we did the assignment here. So it's going to go in and try to find a t. It's going to find the guy here at the first index. And the test here is going to succeed. When it succeeds, it's not going to be equal to null pointer. It's going to be pointing to a valid pointer. And it's going to succeed and return the pointer to be stored in result. After this guy returns, the pointer is going to be stored in the result here. And that's going to be a pointer to this t. And we're going to jump in the body here. I really want you to understand how this thing is going to work. Once we get in the body, we're going to say, we found our target. That's going to be our t, print it out. And it's going to start at this location. Okay, and we're going to print starting from the t here because that's what our result here is pointing to. After we do that, we're going to increment the result to make it point to the next character. If we do that with pointer arithmetic, now we're going to be pointing to the r in here. I hope this makes sense. And we're going to increment our iterations. So we're going to say we have done one iteration and we're going to try and run this again. And by the time we get in here, we're going to have this string here in which we are searching for a t. And a t is going to be found starting at this second t here, the there here. And it's going to find it. It's going to store the pointer to it to result here. Or I should say the search is going to be successful. So we're going to find the pointer to this t and return it from this function here. And the pointer is going to be stored in our result pointer here. We're going to jump in the body and we're going to print, we found the target starting at this t. We're going to print that out. And stdcout is going to print until it meets a null character. So we're going to print this thing through the end. And we're going to put a /n, which is going to move us to the next line. After we do that, we're going to increment result. And result now is going to point to the h here. And we're going to increment iterations. Now we're going to have done 2 iterations by now. And we're going to run the loop again. This time the loop is going to fail because starting from here, we don't have a t. And this function is going to return null pointer. And this test here is going to fail. Okay, we are going to return null pointer. Null pointer is not going to be different from null pointer. So this is going to fail. And we're going to fall down here and say how many iterations we're going to find. So in total, we're going to do 2 iterations and we are going to find 2 t's and we're going to print whatever we find here. Make sure you really understand this. And I put in this example on purpose because it is a little complicated, but it is going to really bring your game up in how you use these functions from the C++ standard library. And you really need to know this. If you have any problem with this, be sure to ask me. I will do the best I can to help you out. So we're going to build this and run this. We're going to build with GCC as always. And we are going to clear and run Rooster. And you're going to see that we are looking for t. We are going to say we found t starting at the t here. So we're going to say tried. Okay, we're going to print all the message out. And the second iteration is going to find t starting at this location here. And we're going to do 2 iterations in total. We're going to comment this out. And again, if you don't understand this, please go through it again. And if you still don't understand, be sure to ask me. I am going to do the best I can to help you out. And some of you might be asking, why did we go through the trouble to store this guy in result? Why don't we use str in the first place in here? And the explanation I can come up with is that you don't really want to modify this guy here because somebody is going to look at this thing and say, this is the message I have in str here. But if you try and modify this in the loop, it's going to be messed up because you're going to be incrementing it and doing all kinds of crazy things on it. So you don't really want to modify this. So a better way to even do this is to mark this as a const pointer. And we know how to do that. So we can say const here. And if you even try to increment str somewhere, you're going to get a compiler error. So let's make sure we see that. For example, we try and do ++str. We're going to get a compiler error because this is a const pointer by now, and this is much safer. Okay, we're going to comment this out and show you something that might throw off many of you guys. So we're going to comment this out, and I am going to bring that in. Okay, let's go down here, and we are going to do basically the same thing, but we will try and use str in the first place here. Okay, this is how we're going to do this. We're going to have our string, we're going to have our target, we're going to have our result here, which is equal to null pointer, and we have our iterations, which is an integer. Let's make this a size t. And what we're going to do in here, we're going to use str to search. Okay, and we're going to basically do the same checks. We're going to jump in here and say we found a target starting at result, and we're going to increment str here because it is not a const pointer. Now, try to go through this thing here and see how many times you're going to loop. Okay, go through it, and when you are done, we're going to try and run this. We're going to build with GCC. The build is going to be good. We are going to clear and run Rooster, and you see that this guy is going to loop 25 times. And this is crazy. Why is this happening? Why is this happening? What we really are doing here, we are not assigning the result in the string that we are searching at. Okay, let's try and go through this a couple of times. So the first time we're going to do our search. Okay, so we're going to search in str, and if we find our target, we're going to return the pointer to the target. If we don't find it, we're going to return a null pointer. The first time we're going to find this t here. Okay, and we're going to return a pointer to it and store that in result. Okay, so after we do this, we're going to fall in our body here, and we're going to say we found t starting at this location here. That's going to work. And we're going to increment str. Okay, notice that we're not incrementing result here. If we increment str, it's going to point to the next character, which is r here. Okay, and we're going to increment our iterations, and we're going to start a loop again. We're going to search in here, and we're going to be searching from this location here. And we're going to find a t starting at this location. We are going to find this t here, and we're going to return that and store that in result. But the problem is that what we are incrementing here, is that we are incrementing one by one. We are not jumping to this t here. And we had a way to jump to this t by assigning the result into the same variable that we are searching in. Okay, so this is going to loop 25 times, and it is not really good. And some of you might try to set up something like this, and it is really not going to be good. Try to go through this, and you're going to see the reason why it is looping 25 times. Okay, I wanted you to see this. Don't do something like this, and we are going to comment this out. The next thing we're going to see is how we can find the last occurrence of a character. And this is a really cool example. I like it. It is going to do something very practical. We are going to take a path, which is going to be an array basically stored in this input array. And we're going to strip off all the things we don't need, and we're going to hunt down for the file name from a full path. And this can be useful in whatever application you are doing. So we are going to hunt for the last occurrence of a backslash character using the strchr facility in the C++ standard library. And you can find the documentation on this guy here. I'm not going to go there. You should really practice to go there and read what these things do. That's why I am leaving in the links to the documentation. You should go there and read. And if you have a problem, you can ask me. I will do the best I can to help you out. So this line here is going to hunt for the last backslash. It's going to find this guy here, and we're going to store a pointer to that in our output character pointer here. After we do that, we're going to say if we found something useful, if this is not null pointer, we're going to print that out. But we don't want to print starting from the backslash. We are going to use pointer arithmetic and move to the next character, which is going to be this h here. So if we print this out, we're going to have hello CPP printed out, because stdc out is going to print until it meets the last null character, and that's going to be after the last P here, because this is a C string literal here. Okay, we're going to build this. The build is going to be good. We're going to clear and run Rooster, and you're going to see that we have hello CPP printed out here. Okay, this is really all we set out to do in this lecture. I apologize that it turned out to be lengthy. These things can take long to explain, and I really wanted you guys to have as many explanations as I could come up with. We are going to stop here in this lecture. In the next one, we're going to see how we can copy and concatenate C strings using the facilities from C string here. Go ahead and finish up here and meet me there. In this lecture, we're going to look at a few more facilities from the C string library, and those are going to allow us to concatenate and copy strings over. The documentation for what we're going to be talking about can be found here. If you go there, you're going to fall on this link here, and you're going to find that C string was originally in the C standard library as string.h, but in C++ we can use it like this. We have a couple of functions. We can copy stuff, we can concatenate, we can get the string length. We have seen this, but now we're going to look at things that allow us to copy and concatenate stuff, because that's something you may want to do a lot. The first example we're going to look at is std_str_cat, which is going to allow you to join strings. Again, you can browse to the documentation here and see more about this facility here, and you're going to see all about it. For now, we're just going to play with it. We're going to set up two arrays. One is going to be called dest. It's going to contain hello. The other is going to be source here, and it's going to contain world. Notice that these are row static arrays that are stored on the stack, and that's how we set them up here. Okay, so we can concatenate strings using the syntax like this. We're going to say std_str_cat. We're going to say the destination string, and we're going to say the source string we want to copy from. Okay, so after we do this, the destination is going to contain these two strings joined together. And before you do this, you have to be sure that your destination string is big enough. And this is a problem because you have to really keep track of your destination string, and it is easy to put in many more characters that can really fit in the destination string. That's the reason many of these functions here are considered unsafe by many compilers. I don't think you can compile this on Visual Studio. It's going to stop you from doing this. Because of this way, you have to keep track of things yourself. But I am just showing you so that you know how to avoid these problems if you happen to be on a compiler that doesn't protect you from this. So we're going to append goodbye world to whatever is in dest. And down here, if we print dest, we're going to have hello world, goodbye world printed out. We are going to play with this in a Visual Studio Code in a minute. Don't worry if any of this doesn't make sense yet. Here is another example of how we can join strings through strcat. We have two strings and we set them up with simple characters like this. You can do this and put in your own null terminating character. This is illegal C++ code. And notice that this array is a dynamic array. It's going to live on the heap because of this new operator here. We also have a source array, which is also going to live on the heap. It is 30 characters long, so it is really long. And we're going to try and concatenate things here. But before we do that, we're going to check their length. We're going to print them out, and we are going to concatenate. The syntax is the same. You are going to say strcat. You're going to specify your destination and your source you're going to be copying stuff from, and you are going to store the result in destination here. What this is going to do, it's going to grab whatever is in source and copy it. So it's going to copy the entire thing here from source, and it's going to append that to whatever we have in destination, starting from the last null character here. So it's going to overwrite from this null character, and it's going to basically copy everything in the destination here. And if we print whatever we have in destination here, we're going to have file load the Phoenix King printed out. And you're going to see that this is going to be the case when we hit Visual Studio Code in a minute. You can also use a version of the strcat version that is going to allow you to specify how many characters you want to concatenate from the source string. In this case, we have destination, which is hello, and we have source, which is there is a bird on my window. And down here, you see that we do strncat. We say the destination, we say the source, and we say how many characters we want copied from the source here. And we say 6 characters. So we are going to count from the source. We're going to say 1, 2, 3, 4, 5, 6. We're going to grab this there string with this space here, and we're going to append that to the source. And that's what we're going to get in here. We're going to say hello space and there, and that's what we're going to have printed out here if we print dest. We can also copy stuff, and the strcpy function here is going to do that. And here we have an example that is going to try and drive this home for you. We have a source string, which is C++, is a multi-purpose programming language. Okay, dest3 here is going to be the same length as source. We made sure of that in here because we're going to grab the length of the source string. Please remember that strlen is not going to count the null character. That's why we are adding a 1 here to account for the null terminating character here. Okay, after that, we're going to jump down here and say strcpy, dest3 and source3. We are basically going to be copying from source and pasting in destination here. That's what we are doing. If we print destination, we're going to see that now it's going to contain whatever we had in source. And this is how you can use these methods here. We also have a version with which we can specify how many characters we want copied from the source. Here we have a source string, which is hello. We have a destination string, which is dest4. And we are going to copy stuff. We're going to copy from the source. We're going to paste in the destination. And we are just going to copy 5 characters. What this is going to do is copy everything from the source and paste in our destination. And it is going to override whatever we have in the starting indexes in destination here. So we're going to have A, B, C, D, E here replaced by hello. And if we print dest here, we're going to have hello F printed out. This is how these things work. And if you wonder how I know how these things work, I just come and read the documentation here. For example, strncpy here, if we click on it, we are going to get the documentation. This is going to say copies at must count characters of the byte string source, including the null terminating character to the character array pointed to by dest. That's what it does. We have the destination, we have the source, and we have how many characters we want copied. And they say a few things you need to be careful about this guy here. One thing that you usually care about is the return value. You see that the return value is going to be the destination string. So if you want this pointer, you can use it. And you can go down and look at a few examples here and play with them to really drive the point home. Okay, now that you have an idea about how these guys work, we are going to head over to Visual Studio Code and play with them right away. Okay, here we are in our working folder. The current project is C string concatenation and copy. That's what we are doing here. We're going to copy our template files and jump to our current project and put them in place. We're going to open this in Visual Studio Code pretty quick. We are going to include C string because that's what we're going to be using here. We are going to bring this up a little bit and we are going to put in our first example here. We have 2 strings, destination and source, and you see that we tried and made sure that they are large enough to contain however many characters we want to put in, and they are row arrays stored on the stack because they are set up like this. And again, you can check out the documentation here if you want to know how this function works. And we are going to call strcat here to concatenate the source to our destination here. So if we do this, we're going to have world here concatenated to what we have in hello here. And we're going to have hello world in place. For example, if we try and print this out, we're going to try and do that. After we do the first concatenation here, let's do that. That's going to be better to show you how these things work. Okay, after the first function here runs, we're going to have source concatenated to destination here. So what we're going to have is hello world stored in destination here. The second concatenation here is going to append goodbye world to whatever we have in destination here. So what we're going to have printed out is, if we print that, of course, is hello world and goodbye world. Okay, we're going to have this printed out. Let's try and run this and actually make sure that that's the case. And then we're going to see how these functions can be unsafe for some compilers. We're going to build this with GCC. You see that it's going to go through. And if we run this, we're going to have hello world, goodbye world printed out. This is what we expect. And again, this function here, strcat, is going to have whatever you have in source, and it is going to append that to whatever you have in destination. And for this to work, you have to be sure that the destination is modifiable. For example, if it was an array of const char, let's do that and show you the compiler error. We should get a compiler error because now destination is not modifiable. It is an array of const characters and we can't modify it. So be sure the destination array is modifiable, and in this case it is. Okay, please note that some of these functions can be treated as unsafe by some compilers, but I tried this out on both on GCC and the compiler from Microsoft, and they work pretty well, so you can try them out here. To prove that, let's go and try and build with the compiler from Microsoft. We have it set up here. So we're going to run the task to build with MSVC here. And you're going to see that the build is going to be good. The build finished successfully. And if we go in, we're going to clear and run Rooster, you're going to see that it is going to do exactly the same thing. But some compilers might give you warnings or errors if you try to do something like this. And the reason is you really have to be careful using these functions, because if, for example, destination array is not large enough, you may do some crazy things running over the bounds of your array, and it can be really bad. For example, if we try and make destination array here, for example, a size of 3, it is possible to do that. And you see that we get a warning from Visual Studio Code. And if we try and build this with GCC, let's try and remove the garbage we have from Visual Studio first. Now that this is clean, we can try and build with GCC. Let's do that. Our compiler, we're going to choose GCC, and you're going to see that it's going to give you an error. It's going to actually protect us from doing something like this, but in some cases, some compilers are not going to stop you from doing this. But any compiler that really respects itself is going to have these safety checks in and is going to protect you from doing something crazy like this. Okay, this is how you can do concatenation using strcat like we did here. Let's try and build and see that now we are building fine, because I don't like these red lines here. The build is good and we are all fine. Now I am going to comment this out, and we're going to see another example of how we can concatenate stuff. We are going to go down here. Let's bring this down and hide this. And we are going to put in our simple example, exactly the same thing we saw in the slides. We have 2 character arrays. They are dynamic arrays, but we initialize them with characters like this. And we make sure to put in our null terminator. We have our source string, which is going to say the Phoenix King, and it's going to have a terminator here. And what we're going to do, we're going to take source and concatenate that to our destination. So what is really going to happen, we are going to overwrite the null terminator here, and we're going to start pasting in things from source here. So after the concatenation is done, what we are doing here, we are concatenating source1 to dest1. We are going to have firelord, the Phoenix King, stored in our destination string here. And notice that we made sure that it is large enough to contain our characters here. And if we print it out, we're going to have the thing printed out. We can try and build with GCC. That's going to go through. Let's bring this up. The build is good. If you go down here, the build is good. We're going to clear and run Rooster. Okay, this is the output here. You see that the destination is 8 characters long. If we count 1, 2, 3, 4, 5, 6, 7, 8. Remember, strlen doesn't count the null characters, so this is what we expect, 8 characters. The source is going to be 17 characters. If you count all this, that's what you're going to get. And if we concatenate them, now destination is going to be 25 characters long in the eyes of strlen. And you see that we print the destination, and it is exactly what we expect. Firelord, the Phoenix King. Okay, we're going to comment this out. I just wanted you to see an example of this. And the one thing I really want to stress in this example is that strcat is going to start overriding whatever is in dest starting at the last null character. Okay, so this guy is going to be overridden by the comma here, and we're going to start inputting stuff, and that's what we're going to see here. Let's comment this out because we want to move on and show you a few other examples. Okay, the next thing we're going to look at is a new version of strcat that allows you to specify how many characters you want concatenated from source. For example, here we have two strings, destination and source, and here we are basically saying I want to concatenate 6 characters from source and put them at the end of the destination here. And what it's going to do, it's going to grab 1, 2, 3, 4, 5, 6. It's going to grab this entire thing, and it's going to append that to hello, and we're going to have hello there stored in the destination. And the return value is going to be a pointer to destination 2. And how do I know the return value? Well, I know that from the documentation. If you go in your favorite search engine and do stdstrncat, and you're going to see a link here. If you click on it from CPP reference, it's going to give you everything you need to know about this function here. It's going to append source to destination, and n count characters are going to be copied. So the third parameter here is going to be how many characters you want copied and pasted into our destination. And the return value is going to be dest. Okay, if we try this out, we're going to see hello there printed out. We're going to print it out directly, and we're going to print that out using the destination pointer that is going to be returned from this guy here. So if we try and build this, we're going to build with GCC. The build is going to be good. We're going to clear and run Rooster, and you're going to see that we have hello there twice here, and this is exactly what we expect. We are going to comment this out, and we are going to go down and look at strcpy, I should say strcpy, which is going to copy stuff from the source and paste those in the destination. And one thing you should know is that the copy is going to happen starting from the start of the destination array. Here we have two arrays. One is called source3, the other is called destination3. Destination 3 is set up on the heap using the new operator, so it is a dynamic array, and you see that we make sure that it is the same size as the source. We are using strlen to figure out how many characters we have in here. And remember that strlen doesn't account for the null character, so we are adding 1 to account for the null character. That's what we are doing here. And after that, we are going to do std strcpy. And what that is going to do is copy stuff from source to destination character by character. So we are basically going to have this guy pasted into destination here. And if we print things out, we're going to see that destination contains the same thing as source here. If we build this with GCC, let's do that. The build is going to be good. We can clear and run Rooster. And you're going to see that the destination has exactly the same thing we had in the source. And if you need to copy stuff from arrays, strcpy is going to be very helpful. We are going to comment this out because we still have a few things we want to see. So let's comment this out. We are going to go down and see that we can also use another version that allows us to specify how many characters we want copied from the source. Okay, in this example here, we are using std strncpy, and this n here means that we can specify the count of characters we do whatever the current function is doing here. Okay, so we are specifying I want 5 characters copied from source, and I want those pasted into destination here. That's what we are saying here. And the source is going to contain hello, destination is going to contain world, and the copy is going to happen starting at the first index here. So we're going to have hello override whatever we have in A, B, C, D, E, because that's 5 characters here. And dest is going to contain hello F if we print it out. Let's build this and see if that's what we're going to get. We're going to build with GCC. The build is going to go through. We are going to clear and run Rooster. And you see that that's exactly what we have here. Okay, this is how these methods work. There are many more functions you can use from the C string library. And again, if you want to see a list of them all, you can go through your favorite search engine and search for C string. and we can specify CPP reference here. Let's try and do that. Okay, we can find a link to that. We can click on that and it's going to open up and show us many more functions we can use. And if you need to know about a special function, you can click on it and see what it does. And if you go down, you're going to find even an example of how you can use it. For now, we are going to stop here in this lecture, and this is actually going to be the last lecture we see on C strings. In the next one, we're going to start and look at std string, which is a compound type that makes working with strings very easy in C++. Go ahead and finish up here and meet me there. In this lecture, we're going to start and learn about std string, which is a type that is going to make it super easy to work with string data. We have seen many ways we can work with character arrays by now. We can use row arrays, we can point to them with pointers, we can even allocate arrays on the heap. But all these character arrays had a few problems that are really a pain in the neck to deal with on a daily basis. One of those problems was that you had to keep the size in check. You have to know how many elements you have in the character array, and that was defining the bounds that you can work in. If you go over bounds, we have seen that that can cause crashes of your program, and you don't want that. Another problem was that we had really to remember to keep track of the null character. If we don't have it in place, we're going to have problems when our string is printed out. And it's really annoying to always have to think about these little details when all you really want is to store a string. So C++ offers a high-level type that we can use, and it is going to hide all these little details underground, and all we have to do is put in our string and use it, and we can be on our merry way and do whatever we want to do with string data in our C++ application. So that's what we're going to do. We're going to have a type that is going to wrap on top of the ugly array computations we have been doing on character arrays. We're going to call that std string, and we're going to be able to do many of the things we were doing with C strings, but in a much better way. We can concatenate, we can search, we can copy, we can do all kinds of crazy things really, but it's going to be in a way that you don't have to worry about these little details about array bounds, the null character. You're going to just use it for what you want, which is storing character or text data. Okay, so that's what we're going to be doing in the next few lectures. We're going to be learning about std string and how you can use it in your C++ applications, and it's going to make your life a whole lot easier. We are going to stop here in this lecture. In the next one, we're going to see how you can declare, initialize, and use std string in your C++ application. Go ahead and finish up here and meet me there. In this lecture, we're going to see how you can declare and use std string in your C++ applications. Std string is a type that is going to wrap on top of arrays and give us a really nice interface that we can use to store string data without having to deal with the ugly little details like keeping track of array bounds, remembering to keep in check the null character, and things like that. To use std string, you will need to include the string library, and after you do this, you can declare and use your strings just like this. Here we have a series of examples just to get you started on this. You declare your strings just like you declare any other type. You specify the type on the left. The type is going to be std string. By the way, you'll have to remember to use std : like this, and we will have a chance to explain why in a few chapters ahead. But for now, we're just going to think of std string as our type. So we declare a string type, we call it full name, and we can leave it like this uninitialized, and it is going to be an empty string. We can also put in our string and initialize that with a string literal, and it is going to work. Another way of doing this is initializing a string with another string, which we are doing down here. We can also set up another string and initialize it with part of another string literal. So for example, message here is going to be hello, and it's only going to grab 5 characters from this string literal. This is something you might want to do if it makes sense for whatever application you are doing here. We can also initialize our string with multiple copies of one character, and this is the syntax to do it. You say the name of your variable, you say however many times you want the character repeated, and you say which character it is, just like this. We can also initialize a string with part of another existing string. So for example, here we have saying hello, and it is initialized with part of what we have in greeting here. So we're going to start at index 6, which is going to be 0, 1, 2, 3, 4, 5, 6 on the W here, and we're going to grab 5 characters. So 1, 2, 3, 4, 5, and that's what we're going to use to initialize this saying hello here. And if we print it out, we're going to see that this is going to be exactly the case. So hopefully you can see that it is easier. You don't have to use pointers, you don't have to use arrays. And the best part is std string can grow automatically if you happen to store in more characters than you initialized it with in the first place. And that's pretty cool. So now we're going to head over to Visual Studio Code and play with us so that you can see for yourself. Okay, here we are in our working folder. The current project is declaring and using std string, which is what we are doing here. We're going to grab our template files pretty quick, and we're going to go in and store in the files, and we're going to open the folder, and we're going to include the string library. Let's do that. Okay, this is how we do it. And now that we have it included in our project, we can start declaring and using std string types in our C++ program. We are going to go down and put in the code to play with this a little bit. So you can declare an empty string like this, and it's not going to have anything inside. You can declare a string and put in a string literal like we are doing here. And std string knows how to handle this, so it's going to store it inside using a character array. But we don't have to really worry about that character array is going to work. We're just going to use std string here. We can set up a string using another string in our initializer like this. We can also use part of a literal to initialize the string. So for example, this string literal here, we're going to grab part of it, and we're going to grab 5 characters and use those to initialize our message std string here. And this is pretty cool. We can also use multiple characters to initialize a string like this. We say however many copies we want of this character in this string here, and it is going to be exactly what we want. So it's going to be 4 E's in this weird message string. And we can initialize a string with part of another string. And this is really cool, and it may come in handy in many applications. So for example, here saying hello is going to contain world here, and we are saying that this is what we want by saying we want to start at index 6 in this string here. So if we go 0, 1, 2, 3, 4, 5, 6, this is going to be our character at index 6. And from this index, we're going to grab 5 characters. So we're going to count 1, 2, 3, 4, 5, and that's going to be what's stored in this string here. And if you don't believe me, we can print all these things out, and they are going to be exactly what we expect. And by this, you can even see that we can print std strings using stdcout very conveniently like this. And this is very cool. Okay, so we can try and build this with GCC. The build is going to go through, so we're going to bring up a terminal so that we can run this. And we're going to clear. And let's see what we see when we run Rooster here. So we're going to print the full name. The full name is empty. Okay, so we're not going to see anything because it is empty. We're going to see planet. Planet is this thing we have in here. Planet where the sky is blue. So this is what we expect. We can say preferred planet and put in the text for the planet here. So we're going to get the same thing here. And if we have a message and say hello there and grab the first characters in this string literal, message is going to say hello, which is what we are saying here. Let's go down and look at weird message. It's going to be 4 E's, which is what we have here. And we can initialize saying hello with part of what we have in greeting, and we have targeted this word string here, and it is what we see here. And this is pretty cool. The good thing about std string, however, is that you can store in more characters than we initialize this guy with. So for example, here we have this message here, but we can say planet. Let's go down here and say it. We're going to change std string at runtime, so we're going to say planet, and we're going to assign something to it. We're going to put in whatever was in there first, and we're going to paste that in multiple times. Let's do 3 times. I think that's going to be enough. Or we can even bring this back so that we see the entire thing here. Doesn't really matter. All we want is for this thing to be larger than it was initially declared in planet here. So we're going to remove these quotes because they are making things ugly for us. And now it's going to be a valid string. Let's wait for Visual Studio Code to realize that. and it's going to remove these squiggly lines. Now we are good. std string is automatically going to take care of the logic to make this string grow. We don't have to worry about that. And if we print planet now, we're going to see the same details and taken care of. Okay, this is really cool, and it makes it super easy to work with text and string data like you see here. So let's build again so that our changes are reflected in our output. We're going to clear and run Rooster, and we're going to see that planet is now really large. Okay, we can change this thing, the size of this thing at runtime, and this is something we couldn't do with arrays. So for example, if we go down here and use a row array to do something like this code is going to run, but try to think about what is really happening here. We have an array which contains this text here, and it is pointed to by this const char pointer that we have. If we try and do an assignment like this is really going to be to make it point to another character array in memory. And this piece of memory here is basically going to be wasted because we think we have our planet string in here. This is not the case with std string, because std string, when we do something like this, the initial memory that was allocated to store planet here is going to be returned to the operating system. And a new memory is going to be allocated to contain this new thing. So the waste we're doing here by just leaving this in memory and not using it is not being done here. So if we try to print, we're going to get the same output, but inside in how our memory is managed, std string is better in that the memory that was used to initialize this guy is not wasted out. Here with array, what we really are doing is just make this planet pointer point to another string and leaving this to be wasted in memory. This is what we are doing here. And we can avoid that with std string. In this lecture, we're going to learn about the one definition rule. And this is a rule that says definitions can't show up more than once in your entire C++ program. Or in some cases, a definition can show up more than once in a translation unit. We are going to look at the one definition rule in the context of freestanding variables, functions, classes, member functions, and static members in our classes. In most cases, a definition can't really show up more than once in your entire C++ program. But we have exceptions to this rule. And the exception is for classes. A definition for a class can show up in multiple translation units, and the reason is we need to create objects of those classes, so each translation unit really needs to see the definition for the class, and we are going to try and make this super clear with examples once we hit Visual Studio Code. Okay, so it is time to head over to Visual Studio Code and shed some more light on the one definition rule. Here we are in our working folder. The current project is one definition rule. We're going to grab our template files like we always do. We're going to put them in place, and we're going to open this little guy in Visual Studio Code. Let's do that. We're going to drag and drop, and we're going to have our main CPP file here. We're going to clean it up. That's what we always do. And now we want to explore the one definition rule in the context of variables. So we have a freestanding variable here. And that's going to be the same variable we had in the last lecture. We're going to initialize this. And this is really good. We can use it. We can go in main and use it however we want. We can print the weight. And if we build and run this program, it is going to work. But the one definition rule says we can't have more than one definition for anything. And for this variable here, we have seen that this is both a declaration and a definition. So we can't have more than one definition for the weight name here. For example, if we try and grab it and copy and paste it here, so we're going to try and build this program. We're going to use GCC. We're going to see that we have a problem, and the problem is going to say redefinition of double weight. And it is not going to help even if you take this and put that in another file. So let's create another file to really show you this. We're going to call it some other file.cpp. And we're going to grab our redefinition and move that there. And you're going to see that if we try and build this program, we're going to get the same problem. We're going to have redefinition. So we're going to see What is the problem here? The compiler error is a little bit different, but it is going to say multiple definitions of weight, and it's going to say one is defined in the main CPP file. So this is a linker error. This was caught by the linker because the redefinition is showing up in multiple files. So the linker was linking this program and it needed to see a definition for weight, and it had seen one definition in the main CPP file, and it has seen another definition in some other file, and this is a problem. The linker doesn't know which one to choose, so it's going to throw an error, and you can't really have multiple definitions for a variable in your C++ program, and this is the one definition rule in the context of freestanding variables like the weight here. But this is the same in the context of functions. If we go down and put up our add function here, we're going to say double A and double B here, and we're going to put the definition below the main CPP file. Let's grab this. We can copy this and put this in the code here. We're going to remove this little thing. We don't want it. We're going to put in our body, and we're going to return A plus B here. Okay, so this is our function. It is working. We can take out what we had here because it has served its purpose. We can say double result, and we're going to add up 10 and 20 like we did in the last lecture. No problem. And we can try and print out our result here. If we build and run this program, it is going to work without a problem because we only have one definition for the add function. What is the problem here? We have weight defined multiple times. We're going to comment out one definition for weight, and we're going to build again. Now the build is good, and we can run this program. We can kill our terminal here and bring up another one and run Rooster. You're going to see that the result is 30, and the program is working just fine. But if we set up another definition for add, even if we put this in the same file, we're going to get a problem because we are violating the one definition rule. Let's run again. You're going to see the problem here. We're going to see redefinition of the add function. This is not allowed. Your program is not going to compile. We see the compiler error here. Even if you put the definition in another file, that's not going to help. We're going to take this and put this in some other file and trying to compile the program. We're going to get a linker error, and it is going to say multiple definition of the add function, and this is not allowed. This is a linker error, and this time, if we comment out one definition, let's do that. We're going to comment out the one in the main function. This is going to work, and we want to be violating the one definition rule. So this is good. The build is good. We can clear and run Rooster. We're going to see our result here. So the one definition rule says you can't have multiple definitions for freestanding variables or even functions. And we saw that if you do that, you're going to get a compiler error. Let's look at this in the context of classes. We're going to do a class. We're going to say struct, and we're going to call this point like we always do. Mostly, we're going to call this point, and we're going to put in a few member variables. One is going to be mx, the other is going to be my, and this is going to be our definition here. But what you're going to see is that it is possible to have multiple definitions for classes. For example, if we take this and have a copy of this in another file, we're going to do that. We're going to declare this structure here, and we're going to try and build this program. You're going to see that it is working. We have multiple definitions of these guys. We can go in main, for example, and say point P1, and we can build and see that the program is going to work. Okay, so if you go in here, for example, and try to print std P1 and print X, we're going to do that. We're going to say P1 MX. We're going to be able to use this because this is a struct. The member variables are public by default. We can do this, and we can say P1Y is P1Y MY. Let's do that, and we can say stdndl. What is the problem here? We need to put our output stream operator. I think now the compiler is going to be happy. And if we build, we're going to use GCC. We're going to see that if we run the program, we're going to see our things here, and we have some junk values inside because these things are not initialized. But if we initialize them to 0 using a braced initialization here, we're going to build again, and we should see 0 inside. So let's clear and run Rooster. Now we have 0 in X and Y for our object here. This is working fine, and we have multiple definitions for our class. But the definitions can't show up in a single translation unit. For example, if we took this definition here and brought that back in main and put that just below our struct here, if we try to build, the compiler is going to complain because now we have multiple definitions for the same class in the same translation unit. For classes, we can have multiple definitions, but the definitions have to show up in different translation units, and that's what I want you to see here. So we have a redefinition of our point struct, and it is not good. It is going to violate the one definition rule. Okay, now that you have seen this, we also want to see this in the context of a class that also has some static member variables. We're going to take this out because we have already seen this, and we're going to bring in our person class like we used in the last lecture. We're going to add in a new header file. It's going to be called person.h, and we're going to jump into, what did we do? Is this a folder? Let's remove this. We didn't want a folder. We're going to delete this folder. We don't want it. And we're going to just add a file called person.h. That's our file here, and we're going to put in the content. The content is going to be our person class. Let's close this so that you can see more of this class here. Okay, so we have our person class here. We have our include guard. We have our person class definition. We have a constructor, and we have a printf function. We have our member variables, and down below here, you see that we have a static variable, which is person count. We need to put in the definition for these guys. So let's go down and do that. We're going to put in the definition for the person constructor. We're going to go on top here and include our person header file, and we're going to put in place our constructor. We can go down and do that. We can say person and say person. That's going to be our constructor. We're going to go back to the class and grab the parameters because I don't want to type all this. Thanks. So let's do that. We're going to put them in. We are going to put in our initializer list. I think we should also delete a parenthesis here. We're going to go down and put in our initializer list. We're going to say full name. We're going to initialize this with name param. And we're going to also put in our age, and we're going to initialize this with age param, the parameter we have from the function. And this is going to be all. Inside the body, we're going to increment the static variable. We're going to say increment person count. We can select that here, and this is going to be good. We also need to initialize our static variable, so we're going to say int person count. Let's do person count, and we're going to initialize this to maybe 8 like we did in the last lecture, and this should be all we need here. So if we build and run this program, I think it's going to run. Let's select the main function here. And what problem do we have here? Let's build and see. We're going to let the compiler figure this out. We're going to see that the build is good, and we can create person objects and really use them in our program. So let's come down here and delete whatever we had. We're going to include person, and we're going to go down here and create a person object. We're going to say person p1, and we're going to specify the name to be Jon Snow. Why not? And we're going to say that they are 35. Why not? And we can print information about this person. We can say person printful. And if we try to build this program, let's use GCC to do that. The build is going to be good. As you see down here, we can clear and run Rooster. We're going to see Jon Snow. He is 35 years old. So this is working just fine. But we can't have multiple definitions for the same class in the same translation unit here. For example, if we come in the main function, notice we are including person. So this is bringing in the definition for person we have in our person.h here. If we also try to declare another class called person, even if we don't put anything in, the compiler is going to complain because we have two definitions for the same name, which is person here. If we try to build I think we are going to get a compiler error saying that we have a redefinition. You see, we have a redefinition of person. So this is not allowed. We can't really do this. But notice that this person class is included both in some other file, which is a separate translation unit, and main. We have it included here. So it is really in a separate translation unit. We have the definition for the class in separate translation units, and that's not a problem. But if you try and put the same definition multiple times in a single translation unit, you're going to get a problem, and you need to be aware of that. What I want you to see right here is that you can't also have multiple definitions for your static variables and the member functions of your class. For example, if we grab what we have here and also put that in our main function, we can do that. Why not? We're going to come in our main function here and we're going to put the same definitions here. Now we're going to have a problem because the linker is going to see two definitions for the static variable and the constructor for person here. And this is going to be a problem. You can't really do that. If we build, we're going to see a problem. We're going to see that the problem is we have multiple definitions for the constructor and we have multiple definitions for person count, and this is not allowed. You can't really do that. You can either remove the one from some other file .cpp, for example. If we comment this out, let's do that. We can come on top here and comment this out and try to build the program. Now the program is going to work because we have one definition for these guys. You see the build is good. We can even run the program to show you that it works. Or we can remove the one in the main CPP file and we can leave this alive. So let's go back in the CPP file, the main CPP file, I should say, and remove this. And if we build, we're going to see that this is going to work. And we are compliant with what the C++ standard expects us to do in our C++ programs. If we run, we're going to see that this is going to work. And this is really cool. This is really all I wanted you to see in this lecture. The one definition rule, which says that you can't have multiple definitions for the same name in your entire C++ program. But for classes, we can violate this rule a little bit and make the same definition show up in multiple translation units. We are going to stop here in this lecture. In the next one, we're going to learn about linkage. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about functions. A function is a reusable piece of code that you can use multiple times to do different things. It can take input, and once it has input, it can do some processing. And when the processing is done, the function can optionally give you a result. You can think of a function as a machine, which can take input and give you some output. When you give input to the machine is going to do some processing, and then it's going to give you the output, and the output is going to be dependent on the input that you gave to the machine. This is really how a function works in C++. And once you have the machine set up, you can really reuse it however many times you want. Let's look at how a function looks in C++. The syntax is this. You first specify the return type, which may be int, double, or whatever. After that, you're going to specify the function name. And after that, you're going to have a pair of parentheses. Inside these parentheses, you're going to have your parameters, which is going to be a comma-separated list of things you pass to the function. And after all these parameters, you're going to have a pair of curly braces. And inside those curly braces, we're going to have the body of the function. We're going to be doing our processing in the body. And when the processing is done, we can get the result of the function through this return mechanism here. So if we want to get something out of the function, we have to return that thing, and it is going to be visible to whoever used this function. Here is a simple example of a function with no input and output. The syntax is going to be this. Void means that this function is not going to return anything. And you notice that our pair of parentheses is empty because we have no input in this function. We have our curly braces, and inside these curly braces is going to be the body of this function. It's going to do some processing. And when processing is done, we return out of this function. Now, remember that I said that this function doesn't return anything because it is of void type here, but we can return. And I'm going to show you the exact syntax of how you can do that. Okay, so we can have many functions in C++, but each function has to be unique. Otherwise, you're going to have problems in your C++ programs. A function is going to be unique based on its signature. And a signature is really a function name plus the function parameters. If we go back to our example here and try to figure out the signature of this function, it's going to be function name and plus the parameters, and you see that we have no parameters in here. So this signature is going to uniquely identify this function in our C++ program. If we set up another function that has this same function name and doesn't take any parameter, we're going to have problems, even if we happen to have a different return value for the function. And don't worry if this is not making sense yet. We will see a lot of examples, and I am sure by the time we are done with this lecture, you'll be a master at using functions. Okay, now that we have seen how we can declare or define a function in C++, let's see how we can use the function. And when you call a function, in most cases, you will want to get something out of that function. So suppose here result var is a variable that is going to catch the result of the function. And we're going to call the function with a syntax like this. We're going to say the function name, we're going to put our pair of parentheses here, and we are going to pass in the arguments or the values of our parameters. This is the syntax. It is going to call the function, and the result of the function is going to be assigned to this result var variable of ours. Here is how you can call a function that doesn't take any parameter. The parameter list is basically going to be empty. And now we're going to look at a few examples of how you can really declare functions in your C++ program. For example, here we have a function called into_bar. It doesn't return anything, so we can't catch the result of this function. And it's going to have one input in the form of an integer. So the parameter is called age here, it's an integer. And inside the function, we are going to test if somebody is old enough to enter a bar. So we do a test to see if the age is greater than 18. If it is, we're going to tell them, please proceed. If the age is not greater than 18, we're going to tell them you cannot enter. This is an example of a function you can set up in your C++ programs. Here is another function that is going to compute the maximum between two numbers. It is going to give us a result, so the return value is an integer here. The function name is max, and we're going to put in our list of parameters. And again, these are the parameters. When you are defining your function, this comma-separated list of things we have in this parenthesis are called parameters. And when you call the function, the values that you pass in the places of these parameters are called arguments. So these are a few terms that can really throw you off, and I just want you to be super clear about these things. Once we have the signature of the function set up, we jump in the body and we do whatever we want this function to do. So we're going to say, if A is greater than B, then A must be the maximum. We're going to send that back to whoever called this function. Or in other words, we're going to return A. And if A is not greater than B, then B must be the maximum, and we're going to return it. That's what we're saying here. Here is another example of a function that doesn't have any output and doesn't take any input. It doesn't return anything because the return type is void, and it doesn't take any input because the parameter list here is empty. In the body of the function, we're just going to greet somebody and tell them, hello there, and we're going to return out of the function. Notice that for a void function, we can either omit the return statement here, or we can just put it in like this, say return and a semicolon, and whatever C++ compiler you are using is going to accept this as valid C++ syntax. Here is another example of a function that returns something but doesn't take any input. The return value is going to be an integer, but we don't need to pass something to this function when we call it. It's just going to give us output. We can call it and get our lucky number and use that however we want in our C++ application. I think we have seen a lot of examples of how we can set up functions. Now let's see how we can call these functions. Here is a simple C++ program. In the main function, we just set up a few variables, a value, b value, a and b here, and we use those variables to call functions. Remember, we set up an enter bar function. The function looked like this, and it was testing to see if somebody's age was greater than 18. If the age is greater than 18, they are going to enter the bar. If the age is not greater than 18, we won't let them in. The function takes input, but it doesn't return anything. So we can call this function like we do here and say enter bar. And you notice that we're not catching something out of this function. We're just going to call it, and we're going to give it input, which is 22 here. And the function is going to do its thing. So it's going to let us in because our age is greater than 18. Down here, you see we are calling the max function here. We are giving it two inputs, a value and b value, and it's going to return something. And the return value of this function is going to be used to initialize this maximum number variable here. This is what we are doing. If we go down, we see that we can call the maximum function directly and use its return value in an std_cout statement here. And this is going to print out the maximum between a and b. And down here, you see we have the function say hello, which is going to just greet somebody and not return anything. Here is another example of how you can call the lucky number. You say lucky number, you pass a pair of parentheses, and this is going to return the lucky number and print it out in this std_cout statement here. Down here, we set up a few variables, a and b, and we are going to use them to call the maximum functions. You see we call max a, b, or we can even pass in number literals like we are doing down here. One thing I want you to be careful about is implicit conversions that might happen when you are calling your functions. Suppose we have a minimum function like we see here, which is going to be taking in integer parameters. But here we are calling the function with f and g, which happen to be of double type like we see on top here. So what is going to happen is the compiler is going to notice that what you are passing in is not really what the function takes. But the compiler knows that it can insert a transformation from double to integer, and it is going to do that without your involvement. So be really careful about implicit conversions and make sure they are working to your advantage. Otherwise, you're going to have really hard to debug problems in your C++ programs. One other thing I want you to be aware of is that if we have a function set up like this function is going to be taking parameters as copies. So if you have two variables, for example, c and d, and you call this function with those two variables, you're not going to be manipulating those two variables. What you will be working with inside the body of this function are going to be copies of the parameters that you passed in here. So if, for example, you happen to increment either of the parameters, for example, here we increment a and we increment b, the changes we make here inside the body of the function are just going to be affecting copies we have inside the function here. And these copies are going to die the moment we hit the end of this function here. This is something I want you to be aware of, and we will play with it in more detail when we hit Visual Studio Code in a minute. Here is a simple example of how you can call that function. We have two variables, h and I, and we are going to print them out. After that, we're going to call the function. We're going to store the result back in increment result. But the important thing is that we call the function here with h and I. Remember, in the body of the function, we are incrementing h and I as arguments, but the changes we do inside the body of the function are not going to be visible when the function returns. If we print h and I here, we're just going to see the same thing we saw before we call the function. I realize this is a lot of information to take in. Now we are going to head over to Visual Studio Code and actually play with this step by step. Okay, here we are in our working directory. The chapter is on functions. The current lecture is first hand on functions. We are going to grab our template files like we always do. We're going to put this in, and we are going to open this in Visual Studio Code. Let's open the folder, and we are going to go in the correct chapter and choose first hand on functions here. This is what we want to open. And we are going to open our main CPP file and clean it up a little bit. And the first thing we want to do is to set up a function that takes a single parameter and doesn't give back any result. So the function is going to be into bar. We have seen that. The function is not going to return anything, so it's going to be void. Its return type is going to be void. The name of the function is going to be into bar. And what we want to pass in here is a variable to represent the age of somebody. And we know that the age can really not be negative, so it is advised to at least use an unsigned integer type. So we're going to use unsigned int, and the parameter name is going to be called age. Once we have our parameter list, we're going to put in the function body, and remember the function body is going to live within these two curly braces. Now this is a valid C++ function. It's not going to return anything. It's going to take a single parameter whose type is unsigned int. Its name is into bar. We can get inside the function and actually do whatever it is we want to do. So once we go in, we're going to test and see if the age is greater than 18, do something. If the age is not greater than 18, we're going to do something else. Let's do that. We're going to say if age is greater than 18, we're going to tell them the age and tell them that they can actually go in. This is logical. And we're going to say else. And in the body of this else block, we're going to say something else. We're going to tell them, sorry, you are too young for this, and we are going to get out of this block here. And this is really our function. Again, let's try to analyze the syntax here. We have the return type. This is required in C++. If you don't put it in, you're going to get a compiler error because you can't have a function without a return type in C++. You notice that we have our squiggly lines here. Visual Studio Code is not happy. So we're going to tell it the return type. We're going to say the function name after that. And after the function name, we're going to pass the parameters. We can have any number of parameters or inputs to the function, but in this case, we just have one because it is enough for our purposes. After that, we have the body, and inside the body, we do whatever it is we want to do in this function here. Because this function returns void, we don't really need to explicitly return from this function here. But this is an exception only for functions that return void. For other return types, you will have to put in the return statement. But even for void functions, you can put the return statement if you want, and you can do that like this. Say return, and you're going to put a semicolon after this. This is also valid C++ syntax. Okay, now we have declared the function. It is a valid C++ function. Let's try and call it. We're going to go down in main because that's where we want to be calling our functions for now. And we are going to say into bar. We're going to call the function, and you use the function name to call it. And you're going to put in a pair of parentheses and pass an argument to the function. Again, what you pass to the function when you call it is called an argument. But what you pass to the function when you are defining it like we did here, that's a parameter. Okay, so function parameters when declaring functions, and when you are calling the function, what you pass are function arguments. And now we need to pass in some age to this function, and let's say 22. And if we do that, this is going to be a valid C++ program. Notice that we have this squiggly line. It is because we forgot a semicolon here, because C++ requires to have a semicolon after each statement. And now we have a valid C++ program that is declaring a function and calling a function down here in main. We can try to build it. Let's use GCC to do that. The build is going to be good. You see, build finished successfully. And we can bring up a terminal and actually try to run this function here. Let's clear and run Rooster because our program is going to be called Rooster like we have been doing all along. And the output is going to be, you are 22, please proceed. Notice that we have this function defined once, but we can call it multiple times. So for example, if you go down here and say into bar, and we give it 15 as the age, and we try and build again. Let's build with GCC. The build is going to be good. We can clear and run rooster. Now it's going to say you are 15. Please proceed. Why is that? What are we really doing here? If age is greater than 10, we said 10 here. We should say 18. Sorry for this. We're going to build again. And now it should behave accordingly. So let's say rooster here. You are 22. Please proceed. You are too young for this. No offense, because the age is 15 here. You can keep calling this function and you're going to see things printing out. You can even call this function in a loop. I can't really resist, so let's do that. We're going to say for size t I and say start from 0, for example, or 1, why not? And we are going to say while I is less than 10 or 20, and we're going to increment I. You already know how to use loops, so we're going to be using this as an example. And we can comment out all these guys in front because we don't want them to print stuff by now. And what we're going to do is call the function with whatever iteration we are at. Notice that we have a size t here, and the function is going to be taking an unsigned integer. So we're going to have implicit conversions from size t to int. Or if we really want this to not cause any problems, we can change the type of our parameter to be size t. This is also valid C++ code. Let's say size t properly. And if we go down here, we're going to say enter bar, and we're going to pass in I. Watch what is going to happen. This is going to loop from 1 all the way to 19, and it's going to be calling this function with whatever iteration we might be at. So it's going to loop from 1 all the way to 18, and it's going to tell us we are too young for this. But for 19, it's going to let us in because we will be old enough to enter a bar. Let's try this. I think it's going to be fun. We're going to build with GCC, and we're going to clear and run rooster. Sorry, you're too young for this. You're too young for this. And once we hit 19, it's going to tell us we are young enough to enter a bar, and we're going to go in and have as much fun as we want. So this is really how you can declare a function. Remember, a function is uniquely identified by its signature, and the signature is really the name of the function and the parameters that you have in here. Okay, once you have the function declared, you're going to do whatever you want in the body. You are going to optionally return something from the function, and once the function is declared or set up, you can go in main and call it and do whatever it is you want with it. Okay, now I think we are mature enough to try out a few other functions. Let's go down and put in another function which is going to compute the maximum of 2 numbers. The signature of this function is going to be its name here and the parameters. Notice that we are taking 2 parameters because we want to be computing the maximum between 2 numbers. And this function is going to return something. We want to get the maximum out of the function and use it to do something else when we call it. So this is the declaration of the function. Once we hit the body of the function, we are going to compute the maximum. We're going to say if a is greater than b, then a must be our maximum. So we're going to return that. And if a is not greater than b, then b must be the maximum. We're going to return b as our maximum here. This is what the function is doing. We can go in main and call it. Let's go down and comment this out because we don't want noise output from these guys. So calling enter bar. That's what we were doing. Now we are calling max. So we're going to go down and set up a variable, call it result, why not? And we're going to compute the maximum between 10 and 20, why not? Okay, so let's see what we get. And we're going to print the maximum this time. We're going to say max is result. Okay, now if we build this program and run it, try to guess what we're going to get. We're going to call the maximum function. And what we pass in here are arguments. Again, we are not passing parameters here. We are going to pass in 10 and 20 as our arguments. And when we call the function, control is going to jump to the body of the function, and we are going to fall inside here. The arguments we're going to pass in are just going to be copied in the function, and we will have them through these names a and b. So we're going to test and see if the first parameter is greater than the second. In this case, the first parameter is not greater than the second because the first one is 10, the second is a 20. Let's go down and see that. And the test here is going to fail, and we're going to run whatever is in the else block here. And we are going to return b as our maximum. When we return b is going to basically be the result of this expression here. And that result is going to be assigned to our result variable, and we're going to print it out with this stdc out statement here. So let's try and build this. We're going to build with GCC. Again, the build is going to be good. We're going to clear and run Rooster. You see that maximum is 20. If we try and change this, for example, make the first parameter 100 and build again, let's see what maximum we get. Going to clear and run Rooster. We're going to say that maximum is 100. And again, you can call this function however many times you want. For example, we can call it again and say result equals max using two variables that we have, let's say x and y, and go on top and declare these two variables. Why not? We're going to say int x, and we're going to put in it 22, and we're going to say int y and put in 44. Why not? And now if we print the result, we're going to get 44 because that's the maximum that was assigned back to our result variable here. Let's build again. We're going to run the task to build with GCC. Can clear and run Rooster. You see max is 44, and this is really how you can declare and use a maximum function like this. We're going to comment this out because we have a few more functions we want to try out. Let's go on top and put in another function, and again notice that we are declaring functions before the main function here. This is a requirement of a C++ compiler because before you use the function must be declared somewhere. So we need to go before the main function and declare our functions here. The function we're going to do now is say hello here. It's not going to take any input and it's not going to give us any output. It's just going to say hello and die off. We can go down and call it. This is going to be super easy. Calling hello. And we're going to call it, say hello. See that even Visual Studio Code knows about this function. We can call it like this. It's going to be activated. So we're going to hit the body of the function. We're going to say hello there. And the function is going to return or die off. Please know that you could omit this return statement for functions that return void. So if we comment this guy out, the function is going to work equally well. You can use this however you want. Now we're just going to build with GCC and see this function run. The build is good. We're going to run Rooster and it is saying hello there. Let's go down and look at another example here. The next function is going to be lucky number. It's not going to take any input, but it is going to give us an output in the form of an integer. So we can call it. Let's go down and comment out saying hello here and say that we want to call lucky number. And we can go down and set up a variable. Let's do that. We're going to say int result. And we are going to brace initialize this guy. So it's going to be initialized to 0. And we're going to say result equals lucky number. And we're going to take the result returned by our lucky number function and assign that to the result variable. And we can print it out if we want. So we can say stdc out and say result. And we're going to put that out here, say result. And if we build and run this program, we're going to get this guy printed out. We should see a 99 because that's what we are returning from our function here. And result is 99 as you see in the output here. So this is really how you can declare your functions. A function has a unique signature. So for example, Intobar here has this particular name and these parameters here. If you go down, max has its own name and the parameters that it takes in. If you go down, say hello and lucky number are different in their own ways. If you try and set up another function that has the same signature as max here, your compiler is going to freak out. Let's try and do that. We're going to set up another function. It's going to have a void return type. We're going to call it max because we want to match this signature here. And we're going to give it two parameters, int a and int b. And we can do whatever we want in this function. Notice that we have a squiggly line. If we open our problems tab here, you're going to see that Visual Studio Code has a few problems with this because we are setting up a function with the same signature twice. Let's try and even make this an int and see what we get. Right now, we don't seem to have a problem, but if we get to run this program, we're going to have problems. Let's go down and actually activate the code to call the max function to really show you this, because you need to know. So we're going to comment out calling lucky number, and we want to call max. We're going to activate the code to call max, and we are going to build this with GCC. Notice what we're going to see. We have problems here. We have a compiler error saying redefinition of int max int. And one might think, what if I name my parameters differently here? For example, I call this guy C and this other guy D. Let's do that. Using different names like this is not going to solve your troubles, because if we try and build again, we're going to get the same compiler error. So this is not going to change a thing. We don't have enough tools to really understand this problem, but know that you can't have two functions with the exact same signature in a single C++ program. And we're going to learn more about this later, but note that the signature of a function must be unique to it throughout your entire C++ program. If you remember this simple rule, you're not going to have many problems. So let's try and build again to make sure we have no more problems in here. The build is good, and we can run the program to see our maximum printed out. So let's do that. Clear rooster, and max is 44. It is exactly what we expect. The last thing I want to do in this lecture is make it super clear in your mind that what we pass to functions we have been setting up so far are copies. So let's go on top and set up a simple function. The function is going to increment and multiply. It returns a double type. The name of the function is increment and multiply, and it is going to take two parameters in, a double A and a double B. Once we hit the body of the function, we're going to increment A and B, the arguments that were passed to the function, and we're going to multiply them, and we're going to store the result of that in a result variable. The result variable is what we're going to return to the function, and whoever called this function is going to use that to do whatever they want. What we really want to see is that the changes we do inside the function are not going to be visible to the arguments that we pass to this function here. To really make this super clear, let's go down in main and set up a few variables. We're going to have a double H and a double I. The values are going to be 3 and 4. We're going to print them out, and we're going to call our increment multiply function. Notice that we pass H and I to the function, and the result of the function is going to be stored in the incmult result variable here. But the return value is really not important. What we want to see is if the changes we do to the arguments are going to be visible on the outside of the function here. So remember, we have H and I here. We pass them to the function. Once we hit the inside of the function, we're going to increment A and B, and we are going to return from the function. So let's see if A, which was a 3, and B, which was a 4, have been incremented to 4 and 5. That's what we want to see. So we're going to build this and run this. So let's use GCC to do that. The build is going to be good. We're going to clear and run rooster. And notice what we have here. Let's go down and look at the variables again. We set up H to contain a 3. So before we increment, H and I are 4. Okay, so that's what we're going to print here. Once we hit the inside of the function, we are going to say what we have inside the function before we do the operation, before the increment. Again, A and B are 4. So these are copies we have inside. We're going to do the increment, and after we have the increment, A and B are going to be 4. But once we hit the outside of the function and print with this guy here, we're going to see that H and I are still 3 and 4. So we didn't really affect H and I when we did this increment here. What we affected are copies that were passed to A and B here. And this is something you need to know, because some people will think that because I pass H and I in my argument list here, I can manipulate h and I. What you are manipulating are copies that were made by the compiler to pass the arguments to the function here. This is something you need to keep in mind, and we will learn more about this, but I wanted you to learn this firsthand. And this is really all we set out to do in this lecture. I hope you have a better understanding of what a function is and what you can do with it in C++. We are going to stop here in this lecture. In the next one, we're going to learn a little more about function declarations and function definitions. Go ahead and finish up here and meet me there. In this lecture, we're going to learn about function declarations and function definitions. The motivation for the topic we're going to be talking about here is that sometimes you really want to separate a function header from its implementation because you don't want to expose all the details about how you do stuff. Let's look at a simple example. In the last lecture, we declared a max function which was computing the maximum between two numbers. The output was an integer, so that's what we returned. The name of the function was max, and we had two parameters, int a and int b. But what we did in the last lecture was crump the entire function body in front of main, but sometimes people don't want to really see the details of how you do stuff. They just want to know a summary of what your function does, what we can get out of the function, and what we need to give to the function for it to do its job. And that's what we're going to see in this lecture. If you look here, we have the function header in front of the main function. And the function header is made up of its return type, the name of the function, and the list of the parameters. And after that, we're going to put a semicolon. This is called a function header or a prototype. And when we do that, the compiler is going to be happy and it's going to work with us to compile our program. But when we get to link our program to really put it together and make one binary, the definition of the function is going to be needed. And if you look after main here, what we have is our function definition. If you look closely, you see that it is exactly the same thing we had in the last lecture. We have our header information. We don't have a semicolon after our parameter list, but we have a pair of curly braces. And inside these curly braces, we have the body of our function. Now, it is really easy to look at this program because we don't have to look at all these details about how this function works. We can get first-hand information on how we can use this function, and that is what most people are going to be interested in about your function. They won't really want to go in and see how you do stuff. They will want to use your function to get the output and use it to do whatever it is they want to do. If you look here in the body of the main function, we have two variables, a and b, and we use them to call the maximum function. We can also set up a minimum function which works in the similar way. And we call another function called incremult, which is going to increment and multiply whatever arguments we pass to this function. So the main idea here is that we can split our function in two parts. One is going to be the function header, which is really going to be the function declaration. And the other is going to be the function body with all the details about how the function works. And that's going to be our function definition. And once we have these two things in place, we can call the function in our main function and do whatever we want with it. Okay, now it should be super clear that we can separate our function in two parts, declaration and definition. And sometimes the declaration part is also called a prototype. That's a prototype of a function, and it is made up of the return type together with the function name, together with the parameters, and after that you're going to add a semicolon to make it valid C++ syntax. And another thing you should know is that the prototype needs to come before wherever it is called. If you're trying to call a function before its prototype is seen in your C++ program, you're going to get a compiler error. And now you might be asking, but why did our programs in the last lecture work? We didn't split things up and our program was working fine. Well, if you put a function definition in front of the main function, that function definition is also going to double as a function declaration. That's why the code in the last lecture worked. Okay, now that you have an idea about what a function declaration and a function definition is, let's head over to Visual Studio Code and play with us. Okay, here we are in our working folder. The current project is function declarations and definitions. We are going to grab our template files like we always do. We're going to put them in place. And we are going to open this guy in Visual Studio Code. Let's do that. We open this up. And we are going to open our main CPP file, clean it up a little bit. And let's close this pane so that we have some breathing space. The first thing we're going to do is set up a maximum function. You already know how to do that. We're going to specify the return type. We are going to specify the function name and the parameters. We're going to take in int a and int b. And we're going to go in and do whatever we need to compute the maximum between these two guys. We're going to say if a is greater than b, then a must be the maximum. So we're going to return that. Else, we are going to return b. Okay, this is the function, and it is really simple. We can go down in main and use it. So let's say int x and put in a 5, for example, and let's say y and put in a 2 or a 3. Put in whatever you want. And then we're going to set up the result variable, which is going to catch the maximum. I think we can do that. And what we're going to assign to this is whatever is returned from our function call. So we're going to call this function with x and y. So we're going to be computing the maximum between 5 and 2 here. The maximum is going to be stored in this result variable, and we're going to print it out. So we're going to say std cout, and we're going to say max as result. This is going to do. Okay, let's try and build this and make sure it actually works. This is nothing new so far. It is everything we have done in the last lecture. Now the build is good. We can clear and run Rooster. We're going to get the maximum as a 5 here. And if we try to change these things, for example, make y a 12 and build again, we're going to use GCC. And we are going to clear these things and run Rooster. We should get max equals 12. This is all fine and dandy. But sometimes we don't really want to have the details about how our function works shown in front of the main function here. And we can split our function in 2 parts, a declaration and a definition. The declaration is really going to be the header part of the function, and that's going to be the return value, the name of the function, and the parameter list. But to make it a valid declaration, we have to put a semicolon after this. So this is our function declaration. Sometimes it is also called a prototype. And please make sure you understand the difference between a prototype and a signature. In the last lecture, we saw that a signature was only made of the name of the function and the parameter list, but the return value was not part of the function signature. But the prototype includes all these guys. So signature doesn't include return type. Okay, so now that we have our function declaration set up, we need to put in a function definition, because if you try to compile this program and link it, you are going to get problems. Let's try and do that before we put in the definition. We can build with GCC. We are learning, so we don't have to fear breaking things a little bit. Let's clear and try to build with GCC. And you're going to see, we have a problem here. And what kind of problem we have? The C++ compiler is going to compile this program, but when we hit the link stage, I realize I haven't really talked about this in more detail, but we will do in this lecture. But the main problem here is that we don't have the definition of this function in place, and the compiler is going to search for it and not find it. And you see that it is saying undefined reference to max. Okay, so it has seen the declaration of the function, but it doesn't know how the function does its job because we don't have a function body in here. So to really make this code work exactly as we want, we need to put in a definition. And the definition can show up anywhere in your C++ program. In this case, we're going to put that after the main function, and the definition is really what we have been using so far as our function definition in the last lecture, but notice that it has the body information. And now when the compiler tries to compile this program, it will know how the maximum function is computing its maximum because we have all that information in here. So let's say that this is our function definition and shows up after main in this case. And we can try and build this and see if the build is good. Now you see the build is good. And if we try to run it, we're going to get our maximum exactly like we did when we had the declaration and the definition cramped up before main here. But hopefully now you can see that our program is much cleaner, because when you look at this, you know that we have a function called max. It's going to take two parameters. It's going to return something, and it is called max, so it must be computing the maximum of these two guys, but we don't really care how this function does its job, how it computes the maximum here. And this is the main message here. We can split our function in two parts, a declaration and a definition. Okay, just to play around, we can also set up a minimum function. Before we do that, let's set up its definition down here. We're just going to copy the maximum and adapt it. We're going to put a copy of that guy here. We're going to call it min. It's going to take two parameters. It's going to return an int. But what we test for is if a is less than b. If a is less than b, then a is our minimum. If a is not less than b, then b must be our minimum. And we can put the declaration of this function on top here. So let's go there and say min and say int a and int b. And now we can change the call here to say min, and it is going to compute the minimum. Why not? Let's do that. We're going to say min here, and we're going to grab whatever is the minimum between x and y here, and that's what we're going to have in this result variable here. Let's do that. We're going to try and use this. The build is good. So we're going to clear and run rooster. Now the minimum is 5. We are calling our minimum function. In the last lecture, we also set up a function to increment and multiply. Let's try and do the same thing, but split that into a declaration and a definition just to practice a little more. We're going to call this increment, and it's going to take a and b in, and inside, and we're not going to put the body on top here. We're going to put the body down with the other definitions that we have for all these other functions for max and min here. So we're going to put in our body. It's really simple. So we're going to put a body inside these curly braces, and we are going to return plus a. We're going to increment a, and we're going to multiply that with an increment of b, and we're going to return that. I think this is going to be valid C++ syntax. And if we try to call this function in main, let's do that. Say increment, and we're going to pass in x and y. The program is going to just work fine. We're going to grab the result and store that in our variable. Let's do that. And we can print the result. And we're going to say result here. This is going to do. And if we build and run this program, we're going to see the output here. Let's see what we get. The result is going to be 78, because if we increment a 5, it becomes a 6. If we increment y, we're going to get 13. 13 times 6 should be 78. Let's be sure. We're going to bring up a calculator. Let's do that so that you know that I am not making these things up. 78. So our program is really working like it should. And this is the main message here. We can really split our functions into a declaration and a definition, and that's going to make our programs much easier to work with and read. One thing you should know is that the names of the variables aren't really important in function declarations like this. So for example, we can take out the a and b here, or we can take out all the variable names in our function declarations. Let's do that. And you might think, is this program going to compile? Well, I hate to break it to you, but it is going to compile. So let's build with GCC. You're going to see that the build is good. So the function header or declaration doesn't really care about the variable names. In the definitions, we care about these variable names because we are going to be using them in the bodies. But if you want, you can leave them out in your function declarations. but I like to keep them in place because I like my functions to be self-documenting. If somebody looks at this, they will know the variable name here, but if you really want, you can leave the variable names out, and it is going to work pretty well. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how we can split our programs in multiple files now that we know how to split into declaration and definition. Go ahead and finish up here and meet me there. In this lecture, we're going to revisit our C++ program compilation model. Along the way, we are also going to see how we can work with functions across multiple files. If you remember, our compilation model looked something like this. You have seen this slide a lot of times by now. What it describes is what happens when we compile our program. The moment we run the compilation command, our C++ program, which lives in the main CPP file by now, is going to be passed through the compiler. The compiler is going to process it, and it is going to come up with a binary executable that is mostly called Rooster in this course. And when we execute this Rooster file or binary file, we're going to get the program to run. The program is going to be executed instruction by instruction when it is loaded by the operating system. And we are mostly going to see the output of that program on the terminal in this course. This is the compilation model we know. But now what we want to do is zoom in on this compilation part here and see what really happens under the hood. We are going to suppose that we have our program which is made of a lot of source files as we have here on the left. Suppose we have 2, 3, or 5 source files, unlike what we have so far, which is one file, the main CPP file. When you compile such a program, you're going to go through a stage called pre-processing. And what this is going to do, it's going to look for your include statements, and it is going to take whatever file you are including, and it is going to paste that in place. So for example, here you see we have an include IOStream statement. When the pre-processing stage is run, this include statement is going to be replaced with whatever we have in this IOStream file here. So this is going to be wiped out, and we're going to put in the content that we have in IOStream in this exact place where we have the include statement. I hope this is clear. So when we go through pre-processing, we're going to have a version of our source files with the included parts put in our source files. We're basically going to go copy everything in that file that we include, and we're going to paste inside our new files here that we're going to be referring to as translation units by now. These are translation units in a C++ program. Once you have these translation units, then you're going to compile them. They are going to go through the compiler. The compiler is going to generate what we call an object file, and this is a binary representation of the content you have in your translation unit. So each translation unit is going to generate one object file. And for example, if you had 20 translation units in your program, you're going to have 20 object files. Once we have object files, they are going to be processed by what we call the linker. And the linker is going to stitch them together and have one single binary file out of all these object files. So we're going to have something like this. And this is basically going to be our binary that we can run on our target operating system. So by now you see that our compilation model has expanded to contain 3 phases. We have pre-processing, compilation, and linking. Now you might be asking, why am I showing you this now? Well, it is going to matter because we're going to split our program across multiple files. Some of those files are going to matter on the compilation phase, and some of those files are going to matter on the linking stage. So we really need to make a clear distinction between compilation and linking here. Okay, this should be a more complete compilation model to go by for now. Now that we know about this compilation model, we can look at how we can split our program across multiple files. Suppose we have 3 functions. One we can use to get the maximum of 2 numbers called max, a function called min we can use to get the minimum between two numbers, and a function we can use to increment and multiply, like we have seen in the last lecture. Now, the two functions max and min are going to live in their own file, and that file is going to be split in two files. We're going to have a header file and a CPP file, which is going to contain the implementation. In the header, what we're going to have is just a prototype. And we are going to set up our code in a way that our incr mult function here is going to live in its own file. We're going to split that in two files. So we're going to have a header file called operations.h, and we're going to have an implementation file called operations.cpp, which is going to contain the implementation of this function here. When we hit the main file, what we're going to do is nothing special. We're just going to include the headers, and we are going to use these functions like we have been using them all along. If you look on the first line here, we are calling max. On the second line, we are calling min. And on the third line here, we are calling incr mult to do whatever it does. Okay, when you start splitting your functions between definitions and declarations, remember the one definition rule. And this says that you can't have a function defined multiple times in your entire C++ application. If you do that, the linker stage is going to find those two functions, and it's going to not know which one you really want to use, and you're going to get a linker error. We're going to see that when we hit Visual Studio Code in a minute. Another thing is that you know that your definition can really live anywhere in your code. The linker is smart enough to parse your entire project looking for the definition for whatever function it found in your source code, and it's going to keep looking until it finishes looking in all translation units, and when it doesn't find the definition, it's going to give you a linker error, which is probably going to say undefined reference to something, and we're going to see an example of this in a minute. Okay, now that you know about this updated compilation model and you have an idea that we can split our functions across multiple files, we're going to head over to Visual Studio Code and play with us. Okay, here we are in our working folder. The current project is multiple files here. We're going to grab our template files. Let's copy that and put that in the project of interest. And we're going to open this in Visual Studio Code. Let's do that. We're going to open the folder. We're going to choose the project and open it. And we are going to open up the main CPP file here and clean it up a little bit. We are going to set up a max function. And remember, the function has to show up before it is used somewhere. And we are going to split this into a definition and a declaration. I think we already know how to do that. So let's do that. We're going to put a definition down here, and we're going to change what we have on top here into a declaration. Let's say that to be super clear. And what we have down here is a definition. And we can call this function. We're going to set up a variable which is going to store our max, for example. And we're going to assign whatever we get from the function to max here. So we want to find the maximum between 34 and 56, for example. And we're going to print this out. We're going to say max is the maximum. And if we build and run this program, let's use GCC to do that. We have a compiler error here. What is that? We need a semicolon, not a colon here. I think the squiggly line is now going to go away, and our things are named the same way. The compiler is not going to like it. Let's bring up a terminal so that we see our problems tab, expression preceding parentheses of Paracal must have. Okay, the problem here is that these two guys, max and max, are called the same, and this is going to confuse the compiler a little bit. So what we're going to do is call this maximum. No big deal here. And we're going to do maximum here. And the compiler is going to be happy. Now we can compile and build this program. Build is good. And if we run it, we should get our maximum printed out. Let's see that the maximum is 56. And if we change 34 here to be 134 and build again, we should grab that as the maximum. Let's see if that's the case here. Run the program. The maximum is 134. So this is working exactly as we want. The next thing we want to do is to split this function across multiple files. So we're going to set up two different files. One is going to be a header file. The other is going to be a CPP file. And you have to follow this structure in C++. So we're going to go on the left here and add a new file. In Visual Studio Code, you can click on this little icon that says new file to create a new file. Once you do that, you're going to be given this little window in which we can type the name of the file. We're going to call this compare.h. It's going to be our header file. And we're going to add another one, which is going to say compare.cpp. Okay, our two files are going to be compare.h and compare.cpp. And they are going to contain our functions to compare stuff. So we're going to have in a function called max and another function called min for computing the minimum. Let's go there and actually do that. We're going to move our declaration in the header file. So your declarations are going to be living in header files. And we're going to grab our definition and move that in another file called compare.cpp. So I'm just going to cut it out and paste that in compare.cpp here. Once we do that, we're going to go back in main and see that we have a problem now. The main function doesn't know what this max function is because it's not declared anymore. And if we're trying to compile our program, we're basically going to get the same error we see here in Visual Studio Code. Identifier max is undefined because it doesn't know what this function is. If we ignore this and try to build, let's do that. We are learning, so no big deal here. We're going to get an even much weirder error, but the message is going to be the same. Max was not declared in the scope, so the compiler doesn't know what to do with whatever we typed here. But there is a way in C++ we can solve this problem by including the header that contains our declaration for the function that we are using here. We can go back in main and do that, and we're going to say include, and we're going to say compare.h. That's going to bring in our header, and if you wait a minute, you're going to see that the squiggly line is going to go away. So what happened, the preprocessor is going to come in and copy whatever we have inside compare.h. It's basically going to go in compare.h, copy everything we have in here, and come back in main and paste all that in the place where we have the include directive here. This is called an include directive or an include preprocessor directive. This is what the preprocessor is going to do here. And now if we try to build this program, let's try to do that. We should be fine. Build, finished successfully. And we can run our program to see the maximum printed out. Let's run Rooster. Maximum is 134. Now everything is working. Let's add another function here because just having one function is really boring. So we're going to put in a main function. It's going to take int a and int b. And we're going to go in the CPP file and put in another definition for the minimum function here. We're going to call this min. Let's do that. Let's call this min. And we're going to test for a is less than b. This is going to give us our minimum. And now if we go back in main CPP, we will be able to use our minimum function because it is brought in also by this preprocessor directive we have here. So we can go down and say int minimum, and we're going to say min, and let's grab 146 and 23, why not? And we're going to print the minimum here, and we're going to build this with GCC. The build is going to be good. If we run this, we should see both the maximum and the minimum from these calls we make here. Okay, by now you should have an idea about how to split your functions across multiple files. You should also know that you will have to include whatever header contains the declarations for the functions that you want to use. Another thing I want you to see is that the definitions for your functions don't have to live in a file that is named the same as the header file. For example, here our header file is called compare, and compare.cpp contains our definitions. But the definitions don't have to live here. They can really live in any translation unit that you have in your C++ program. In our C++ programs, the translation unit is mostly equivalent to a CPP file. So let's set up another file and show you that we can move this definition there and the program is going to keep working. We're going to add another CPP file and call it some other file. .cpp. It has to be a CPP file because it's going to contain the implementations. And let's take the implementations, for example. Let's take them all and put them in another file. Why not? We're going to grab all these guys here. Let's cut them out and put them in some other file. And we're going to build this and see that it works. It should, because the linker is smart enough to go find these definitions and whatever translation unit that we have set up in our project here. And you see the build is good. We can build this, we can run this, I should say, and we're going to have our output here. We can even take one of these guys, let it live in our compare.cpp file. For example, let's take the minimum function here, and we're going to bring that back, and we're going to build. Notice that now our maximum function is living in some other file, and the minimum function definition is living in compare.cpp. But if we build, this is going to work. Again, the linker is going to parse all the translation units looking for whatever definition it needs to find. And in this case, it will be looking for the maximum here, and it's going to find that in some other file. And for the minimum function here, it's going to be looking and compare, and it is going to find it. And the build is going to be good, and we can run the program again and see our output here. One thing I really need to point out is that if the definition is not available, let's say the minimum function here is not there, we can comment it out to hide it to the compiler or hide it from the compiler. And if we try to build now, we will get a linker error. Let's try to build with GCC. Build finished with errors. The terminal process terminated with execute code -1. But the main message here is that we have an undefined reference to main int end. So when we compile, the compiler is going to be happy with the declarations that it has found in our compare.h file. If we go there, you see that we have a declaration for max and a declaration for min. The compiler is going to be happy. It's going to compile our code. And when the compiler compiles, it's going to generate object files, and it will hand the job over to the linker to stitch all those little object files together to have one single binary file. When the linker tries to do that, it's going to look at main because that's where it's mostly going to start from. And it's going to see, main is calling minimum here. Where is the definition for the minimum function? It's going to parse every single translation unit in the project. It's going to come here in compare.cpp, it's not going to find it. It's going to look in main.cpp, it's not going to find it. It's going to look in some other file, it's not going to find the definition. And the linker is going to say, I didn't find my definition for the minimum function, so I'm going to throw a linker error, and you, the developer, you're going to fix this problem. And you're going to see this error here. And again, this is a linker error. GCC doesn't give you more visible stuff to show you that this is a linker error, but what you should look for is LD returned 1 here, because LD is the linker that GCC uses. So this is a linker error. I think I should show you how a linker error looks if you are using a Microsoft compiler. So we're going to build again, but now we're going to build with MSVC. If you don't have Visual Studio, that's not a problem. You can keep using GCC, but I just want you to see how different compilers handle these errors. I have the luxury to do that because I am developing this course on a Windows machine, and I have a Microsoft compiler handy that we can use directly from Visual Studio Code here. So I am going to choose this compiler, and you're going to see that it is going to start building. It is building. And it is going to fail and throw a linker error also. So you see here some other object file. Okay. When this object file was being taken and stitched together with other object files to put together our binary, it didn't find the definition for the minimum function, and it is going to throw a linker error. And in Visual Studio, you're going to have a problem like this, LNK, and it's going to give whatever version of the compiler you are using. But down here you see unresolved external symbol. This is how Visual Studio says it. And it's basically going to be an undefined reference to something. This is just Visual Studio's compiler's way to say this. And again, it's going to say this is a linker error here. It is basically the same error we saw when we were using GCC in a minute. Visual Studio, the compiler from Microsoft, is also going to put a lot of junk in our folder here. So let's remove all these things. I'm going to select them all and I hit delete here. And they are going to go to my recycle bin. And we have another one here we should remove. Let's remove it. And now we should go back in some other file, .cpp or compare.cpp. That's where we have our minimum function. We can activate it. And if we build now, the build should be good because the linker is going to find this definition here. Okay, let's build with GCC because that's my favorite compiler. Now you see that the build is good. We can clear and run Rooster, and our program is going to work as it should. This is really how you can split your functions across multiple files. The headers are going to contain the declarations. The CPP files are going to contain the definitions. Your definitions can really live anywhere. It's going to be a matter of what works better for your project. But for organization purposes, your CPP files are going to be basically like this. You're going to have some declarations in the header like compare.h. And in a corresponding CPP file, you're going to have the definitions for whatever declarations you have in the header. But you don't have to do it this way. If it makes sense for your definition to show up somewhere else, please go ahead and do that. C++ is going to accept that. This is really all we set out to do in this lecture. But before we go, I'm going to give you a chance to set up another function. Suppose we have a function called anchor mult, and we're going to have the function set up in here. We're going to return a++. We already know how to do these things. We've used this example a couple of times by now, ++b, and that's what we're going to return. Now your job is to split this function into a declaration and a definition and put those in two separate files. One is going to be called operations.h and the other is going to be called operations.cpp. Pause the video, go ahead, set up your project like that and call that function in main CPP and see if you can pull that together. Okay, pause the video, do that, and once you are done, come back again and see how I do this. So we're going to set up a new file called operations here. It's going to be a header file, .h, and we're going to add another file called operations.cpp. That's going to be our CPP file, which is going to contain our definitions. We're going to go back in main and grab the entire function here. We don't want it in main. So we're going to go in the header here. We should go in the operations header. That's where we want this. And we're going to put in our definition. And we're going to put in our declaration. The declaration doesn't have a body, so we're just going to put a semicolon at the end here. You already know this. We're going to go in the CPP file and put in our definition. This is going to work. And to be able to use this function, we will need to include the corresponding header here. Why is this file called? Oh, it's called CCP. It's CPP. We're going to rename it. And we're going to change this to CPP. Okay, now we should be fine. We should have our things colored properly. And to use this function, we will need to include the corresponding header, which is operations.h. Let's do that. We're going to go in main and go down and include operations.h. This is going to work. And notice that the way we include our own headers is different from the way we include the libraries or headers that come with the C++ standard library. This is a convention that is used by many compilers. This is how we will have to do things. Please remember this. If you are including your own header, please put that in the quotes like we do here. If you are including a standard library header, please use angle brackets like this. Now that we have this included, we can go down here and say result. We're going to set up two variables, x and y. Why not? We're going to have a 4 here. And we're going to have a y, which is a 5. Let's do that. And we're going to have an integer to store our result. It's going to say incr mult, and it's going to do the operations on x and y. Let's do that. And we're going to print the result here. So we're going to say result. And it's going to be whatever we have in that variable. Okay, if we build this program, it is going to work. We're going to use GCC to build. The build is good. If we run it, we should see our output here. We're going to run Rooster, and the result is 24 because, okay, if we increment x, we're going to get a 5. And if we increment a 5, we're going to get a 6. If we multiply these guys, we should get a 30, and that's not what we have here. So what is happening? Let's look at our definition here. We said a++. We should say ++a because we want to increment immediately. Okay, let's build again. We are going to build successfully, and we are going to clear and run Rooster. Now we have the result that we expect. Let's go back in main and look at our program. This is what we are using here, and this is the output we expect. This is really all we set out to do in this lecture, showing you how you can set up your project to split functions across multiple files. This is really good if you want to organize your project. For example, somebody who comes to the header here is not going to be bothered by looking at all the definitions and the details of how we compute this maximum and minimum. And we have the flexibility now to move our headers in some other file because we really want to keep the main function or the main file here really clean. We don't want all those definitions to show up here because it is possible for your project to contain hundreds or even thousands of definitions. If you make all those declarations show up in the main CPP file here, that's going to be really hard to follow and work with. Now we have the flexibility to split those guys across multiple files, and we can even use lots of headers if that is what is going to work for our project. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we're going to see how we can pass parameters to functions by value. Go ahead and finish up here and meet me there. In this lecture, we're going to see what is meant by passing parameters to a function by value. And we're going to look at an example of that. Here we have a simple function called, say, age. It's going to take one parameter, which is an integer called age. And in the body of the function, we are printing out the age after incrementing it. Suppose this is something useful for your program. The function is split into declaration and definition. We have a declaration on top here, and we have our definition below the main function. In the main function, we will attempt to use this function. We're going to call it down here, and we're going to pass a local variable, which is called age, as our age. When we do that, we expect this to print you are 24 years old because we're going to increment the age, and we're going to say, hello, you are 24 years old. This is what this program is going to do. But we want to keep track of how the outside variable here is going to change and the age we have passed as a parameter here. Because this age we pass as a parameter is not going to be the same as the age we have on top here. What we pass here as a parameter is going to be a copy of the actual variable that we passed here. And this mechanism is called passing a parameter by value. And what you really pass is going to be a copy, and what you work on inside the body of the function is not going to be the original stuff you passed as an argument to the function. So we're going to try and prove that here. We're going to print the age before we call the function. We're going to print the age after we call the function. And what we print here is going to be the outside variable because here we are in the scope of the main function. Inside the sayAge function, what we're going to be modifying is a local copy. So we expect the age here to stay the same before and after the function call. So the way this is going to work, when control hits this function here, it's like we're going to have a situation like we have here on the left. We're going to set up local copies in the function that are going to contain whatever was passed as an argument to this function. And this age here was passed as an argument to our function. So we're going to have a local copy of this age and we're going to store it. And it is what we're going to be manipulating in our program. When the function goes out of scope, the local copy is going to die, and the outside variable we have here is basically going to be unaffected. Let's head over to Visual Studio Code and show you this in action. Okay, here we are in our working folder. The current project is passed by value. We're going to grab our template files and we're going to put them in place in the correct project. And we're going to open this up in Visual Studio Code. Let's do that. We're going to open the folder that contains the project passed by value. Let's do that. We are going to open it up and we're going to go in the file and clean it up a little bit. And we are going to set up our function. It's going to not return anything and it's going to say age and it's going to take an integer, which is going to be our age. And inside we're going to increment our age. I think this is what we saw in the slides. And we're going to say however many years you are old. We're going to say hello, you are age old. And we can set up a variable in the main function. We're going to call it age. And it is going to contain 23 as our age. We're going to say age and we're going to pass in our age here. We can do that. If we're trying to run this program, let's try to do that. We're going to build with GCC and we are going to bring in a terminal we can use to run this program easily from Visual Studio Code here. Let's run Rooster. We're going to say, hello, you are 24 years old. And this is what we expect because when this function is called, we're going to increment the age, then we're going to say the age. But we want to see what happens to the outside age here if we modify the inside age that we have on this function here that was passed as an argument. And again, what you pass when you are declaring your function is a parameter, and what you pass when you are calling the function is called an argument in C++. Please remember this. Okay, what we pass as an argument is our int age variable, which is local to the main function. And we're going to see what happens to it. Let's print the age and say age before call. I think this is descriptive enough and we're going to print that. And we're going to go after the function is called, we're going to say the same thing, but we're going to say after call. And by after, we mean after we call the function say age here. I think this is descriptive enough. And we're going to see that if incrementing the local variable to the function here affects the variable that we have in the scope of the main function. Okay, so let's see that. We're going to build with GCC as always. And the build is good, so let's clear and run Rooster. You're going to see that before the call we have 23 and after the call we have 23. We didn't change the second call. This is a classical copy-paste error. We're going to change that for our program to really be descriptive enough. Okay, the build is good. We can clear and run Rooster. And now we have before call 23, after call age is 23. It wasn't changed by what we have inside here. And we can even go further and look at the memory addresses of these guys. Here we can try and print the address of the age variable. Let's do that. We're going to say address of age and put that out here. We're going to say address of age. No big deal here. We can close the pane on the left here because it is taking up valuable space. And we're going to go to the second statement and put in the address of age. And we're going to print that out. We can do that. Now we know the address of operator. Okay, we can do that. And when we hit the body of our function here, we can also print the address of age. No big deal. So we can say address of age. Let's do that here. And we're going to print the address of the local age variable here, which was passed as a parameter here. Okay, now we can build our program and watch those addresses. We're going to build with GCC. The build is good. We can clear and run a rooster. Now you see that the outside variable is going to live at an address that ends in DEC, and the local variable is going to live at an address that ends in DC0. So this is a completely new memory location that we are using, and it is just going to contain a copy of what we passed as a parameter here. And the compiler is going to take care of setting up this copy variable and have it available for use in the local function here. We don't have to worry about that, but we have to be aware that what we are working on in the say age function here is a copy. It's not the original value. This is really all we set out to do in this lecture, making you aware of the call by value mechanism. And the main message is that what you are working on in the body of your function when it is called is going to be a copy of what you have passed as an argument when your function was called here. In this lecture, we're going to see how we can pass parameters to functions by pointer. This is going to allow us to avoid the copies that we were experiencing when we were passing parameters by value like we have seen in the last few lectures. Here is a simple example showing the syntax we can use to pass parameters by pointer. On top here we have our function declaration, and down here we have our function definition. And you see that the syntax is the same. We are passing by pointer and by pointer in the definition here. And another thing you should be careful about is that when you call a function that passes by pointer, you have to give it an address. And that's what we are doing here. So we are passing the address of our age variable, which is going to be passed by pointer. When we pass by pointer, we want to be modifying a copy inside the body of our function. If you look here, we are incrementing the age variable, but we are doing this through dereferencing. So when we pass a pointer here, the pointer is going to contain the address of this guy, and in the body of the function, the pointer we will have, this age pointer, is going to be pointing to the original variable here. Okay, so this age pointer is going to be pointing to the original age variable. When we dereference it and modify the variable, we're going to be affecting the original variable. I really hope this makes sense. And this is really what passing by pointer is all about. You declare your functions by passing in pointers like this, and in the definition you do the same. And when you call the function, you need to pass in an address of the variable, because that's what we store in a pointer here, and this is going to work. If we try to run this example, here we're going to print 23 because that's the original value. We are going to call the say age, we are going to increment, and this is going to change the original value. If we print here, we're going to get 24. And when this function terminates, we're going to hit this statement here and we're going to print 24. This is what we're going to see when we get to run this program here. And this is really all there is about passing by pointer. We are going to head over to Visual Studio Code and play with us a little more. Okay, here we are in our working folder. The current project is passed by pointer. We are going to grab our template files here, and we're going to put them in the current project, which is passed by pointer. We are going to open this in Visual Studio Code pretty quick. We're going to choose that, pass by pointer. We open this, and our main CPP file should show up here. We're going to clean it up a little bit. We are actually going to grab the code from the last lecture and put that in here, and that's going to be our starting point. Let's close the left pane here so that we have some breathing space. The function here, say age, is going to pass by pointer, so we should take out this const here and have a pointer here like we had in the slides. We're going to do the same in our definition here. If we go down, we're going to do that. We're going to pass by pointer, and we are going to uncomment the line that increments our age here. Okay, after we do that, you see that we have a squiggly line at this line that calls the say age function. What we need to do is to pass it the address of the age variable here, like we saw in the slides. So this is the syntax we have to follow. Once we do this, this program is going to be valid, and if we run it, Here we're going to print 23 because that's the value we have in here. We're going to call the sayAge function. We are going to increment age, and here we forgot to do our dereferencing. So what we need to do here is to dereference the age and increment it. This is going to increment the original variable here, and we're going to be accessing this through the dereferencing operator of our pointer here. If we hit this line in the function here, we're going to print 24 because the value has been incremented through this statement here. And after the function call, we're going to hit this statement here on line 10, and it is going to print 24. This is what we expect. Take a moment to make sure you really understand this. The things you need to be careful about is the syntax we use to declare the function. Here we say that we are passing by pointer because of this little star here. And we have the same thing when we hit the definition of the function. We have this little star. So we are passing by pointer. Another thing you should remember is to pass the address of a variable when you call the function like we do here. And please remember to use the dereference operator whenever you want to modify whatever variable is living at the address that you passed in here. So that's why we are dereferencing here through the star operator like we are doing here. This is really all you need to be careful about. So we are going to try and run this program. Let's do that. We're going to build with GCC. The build is going to go through. We need to bring in a terminal so that we can run this program. And again, we expect to see a 23, 24, and 24 here printed out. So let's run Rooster. Okay, here is our output before we call the sayAge function. The age is 23, the address is DEC. When we hit the function, we are saying, hello, you are years old. So here we should have dereferenced to access something inside the variable here. So we should say you are age old. We need to dereference this guy because now it is a pointer. I forgot that. I really am sorry, but we are learning, so this is a good learning chance for you not to make the same mistake as I am making here. So let's try and build again. We should see the correct output. We are going to clear and run Rooster. Now we see that before the call, age is 23. When we call the function, age becomes 24 because we just incremented through our dereference operator. And after the function call, the age is going to be 24 because we have modified the original variable here through our dereferencing of the pointer here. This is really all there is about passing by pointer. This is the syntax. You have to pass a pointer in the declaration. You have to pass a pointer in the function definition. And when you call the function, you have to use the address of the variable and pass that as an argument to the function. And whenever you need to use the passed parameter, you're going to go through the dereference operator like we did here and here in the body of our function here. In this lecture, we're going to see how we can pass parameters to a function by reference. And this is another technique we can use to avoid passing by value, which is going to create a copy. And the syntax is really simple. If you look at the declaration here, you're going to see that we say int reference. And again, if we hit the definition, we're going to say int reference, as you see here. When we call the function, we don't have to pass the address of operator. We just pass the variable because this is going to be treated as a reference by the compiler. And in the body of the function, we don't have to go through ugly dereferencing like we did with pointers. And hopefully you can see that if you want to avoid copies, passing by references is much cleaner. You don't have to use the address of operator when you call the function like we do here. And you don't have to go through dereferencing to access and modify your variables. And the modification we do here by incrementing age is going to be seen on the outside because we are going through a reference. And the reference is a true alias to the variable that the reference is referencing. So by incrementing the age here in the body of the function, the change is going to be seen after the function call. Before the function here, we're going to get 23. In the body of the function, we're going to get 24 because we just incremented the function. And after the function call, we're going to get a 24 because the change was propagated to the original variable. And the reason is because we are going through a reference here. Let's head to Visual Studio Code and actually play with this a little more. Okay, here we are in Visual Studio Code. The current project is passed by reference 1710 here. So we're going to grab our template files and put them in place 1710. Let's do that. And we are going to open this in Visual Studio Code pretty quick. Let's do that. The main CPP file is going to show up here. Again, we are going to grab the code from the last lecture and use that as a starting point. And we're going to be modifying the signature of our function here. So what we want to do is to pass by reference. We're going to say int reference here. You already know references from a previous chapter. And we are going to hit the definition here and do the same thing. So let's say int reference age. And when we call the function, we don't need to pass the address of operator because this is a reference. We can use it right away. The compiler is going to know that this is going to be a reference to the original variable that we pass here. And in the body of the function, let's take out this last line here. We don't need it. And in the body, when we want to modify the reference, we can do that right away without the referencing. So we can just say ++h here, and the changes are going to be propagated to the original variable here because we are going through a reference. Let's go down and modify this because this is a reference. We can use it right away. And we can close this left pane here so that we have some more breathing space. And you see that Visual Studio Code is no longer giving us any squiggly lines. So this must be valid C++ code. Again, notice the syntaxes we are using here. We are passing a reference in our declaration. We are passing a reference in our function definition here. When we call the function, we don't need to do any address of operator. We pass the variable as is. And in the body of the function, we don't have to do any dereferencing. We can increment right away or modify the variable however we want. The changes are going to be propagated to the original variable because we are passing a reference. So the incrementation here is also going to affect the original variable that was declared in the main function here. Let's take this out. And down here, if we need to use our variable, we're going to just use it right away. We don't need any dereferencing. And if we print the address of age here, we're going to see the same address we see on the outside because this is a true alias. It's going to be referencing the same variable that we have in main here. Okay, now that you have a better idea about this, we are going to try and build this. We're going to use GCC as always. You can see that the build is good. If we bring up a terminal to try and run this program, we can clear and run Rooster. We're going to see that before we call the function, the age is 23, but the address ends in DEC. When we hit the function, the age is 24 because we just incremented that here. But notice that the address of the variable is the same as on the outside. So we are modifying the same variable. And when the function is done, the age is still going to be 24 because we just modified the original variable through a reference here. Okay, this is the effect of passing by reference. You can use a clean syntax to modify the original variable in your functions. And this is going to avoid copies like we have seen when we were passing parameters by value a few lectures back. I would like to welcome you in this new chapter where we will be focusing on how to get data out of functions. Again, the model of a function is really what you see here. It is like a machine and you can give input to that machine and you expect to get something out of that machine. This chapter is going to focus on this part here, and we're going to see the different facilities offered by the C++ programming language to get output from functions. And we are going to start in the next lecture and see how we can use input and output parameters. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can use function parameters to get data out of the function. Here is a simple example, and we have three functions here. We have maxstr, maxEnt and maxDouble. And you notice that we have three parameters for each of these functions. The first two parameters are going to be input. They are going to get data in the function. And the third one is going to be the output parameter, and it is going to get data out of the function. Let's focus on maxstr here and really drive the point home. The key idea here is that for the third parameter, we are using a modifiable reference. And if we use a reference, the changes we do inside the function are also going to be visible on the outside. And we explicitly left out the const that we have on the other parameters because we want to be able to modify the output variable here inside the function. If we marked the third parameter as const, we would get a compiler error if we tried to do something like this and assign something to the output parameter here. So the main purpose of this function is to compute the maximum between these two strings. We are going to say if input 1 is greater than input 2, then input 1 is going to be our maximum, and we are going to store that in our output parameter here. If input 1 is not greater than input 2, then input 2 is our maximum. We're going to store that in our output, and whoever has access to input 2 outside the function is going to see the changes that we are making in the body of the function. This is really the technique we can use to send output from the function and make it visible when the function has returned. And again, the key idea is that we set up the function in a way that the changes we do inside the function are going to be visible on the outside. And we are able to do that because output here is a reference. This is really key. We have used references here, but we can set up the same thing using pointers because we have seen that with pointers we can also make our changes inside the function visible to the outside. The two other examples here are really extensions of the same thing. We have two input variables, input 1 and input 2, and output is going to store the output from the function. You notice that output is a reference, and because of this, the changes we do in here are going to be visible when this function has returned. And we do exactly the same thing on maxDouble here, but you see that it is using a pointer. Okay, I really wanted you to see this. So inside, we're going to try and figure out who is the maximum. And if input 1 is the maximum, we're going to write that in our output variable here. And you notice that we are dereferencing here because this guy is a pointer. And if input 2 is our maximum, we're going to write that in our output variable here. One thing I don't think I explained here is that we have a const std string reference here for maxstr. And the reason is that the input variables aren't really meant to be changed. That's why we mark them as const. And if you want to modify them in some way, you can take the const away and it is going to work. Okay, this is really the big idea we are playing with in this lecture, using function parameters as a way to output data from the function. And here are a few ideas you should keep in mind. Output parameters should be passed in such a way that you can modify the arguments from the inside the functions. And we have seen that we have two ways to do that. We could either use references or even use pointers, but references are what you should prefer in modern C++. Input parameters shouldn't be modified. They are meant to just get data in the function, and that's why in most cases you're going to see that they are marked const. Okay, now that we have seen all these ideas, I think it is time we headed over to Visual Studio Code and actually played with them. Okay, here we are in our working folder. The current project is input and output parameters. We are going to grab our template files like we always do. We're going to put them in place, and we are going to open this guy in Visual Studio Code. We're going to just drag it and drop on top of Visual Studio Code here, and it is going to open up. We have our main function here. We can close the pane here and clean the file up a little bit. We're going to remove what we don't need here, and we're going to have a bare main function we can play with here. The first thing we're going to do is to put in our maxstr function. It is nothing special. We just have 2 input parameters and 1 output parameter. The output parameter is going to be what we use to get output outside the function. And inside, we're just going to compute the maximum. If input 1 is the maximum, we're going to write that in our output parameter. If input 2 happens to be our maximum, we're going to write that in our output parameter. Because our output parameter is a reference, the changes we make inside the function are going to be visible on the outside because we will be working on the original variable through the reference, which is really a true alias here. Okay, now that we have the function set up like this, we can head in the main function and try it out. We're going to set up 3 variables of type std string. I think we should include the string library here. Let's do that. And we're going to have an out string, which is going to be our output variable. And we have 2 input strings. One is initialized with Alabama, the other is initialized with Bellevue, and we're going to call our maxstr function here. You notice that it's not going to be using the return mechanism. We're going to be grabbing the output from this function using an output parameter, which is going to be our outstr variable here. Okay, once the function is done, we're going to have the maximum stored in our outstr variable here, and we can print it out. Now that we have this set up, we can actually try and build this. We're going to use GCC. Let's do that. The build is good. We can bring up a terminal and clear and run Rooster. Now you see that the maximum is going to be Bellevue. Let's try and change this to Casablanca. Why not? And we're going to see that the maximum now is going to be Casablanca, and our function is going to be smart enough to store the maximum in this output variable here. Let's build again. The build is going to be good. I'm going to clear and run Rooster. Now the maximum is Casablanca. Hopefully you understand that we are able to make the changes in the function persist because our output parameter here is passed by reference. This is a true reference, and any change we do to the output parameter here is going to be visible in whatever variable you passed as an argument for this third argument here. This is what is making this work. Now that this is working, we're going to comment this out and put in another example for you to play with. The next function we're going to play with is going to be maxent, as you see here, and it is very similar to our maxstr, but you notice that our inputs are no longer references. Because we don't really mind copying fundamental types in C++, they are small in memory, so copying them is really cheap. We can pass them by value, and this is not going to be so wasteful in our program. But the first parameter must be passed by reference because we want to use it as an output parameter, and we're going to use it to get output from the function. And the way we're going to do that, we're going to write whatever variable is the maximum in our output parameter, and the changes are going to be visible on the outside. Now we are going to head over in our main function, set up a few variables, and play with us. So we're going to say int out int. This is going to be our output variable, and we're going to say input 1. Let's say in1, and we're going to initialize this with a 45. Why not? And we're going to say int in2, and we're going to initialize this with 23. Why not? Now that we have this, we're going to say maxent, and we're going to put in our input. We're going to say in1 and in2. Then we're going to say outint as our output variable. Now that we have this, we can actually print out whatever number is the maximum through an output statement like this. Really simple. We're going to say maxent, and we're going to say outint. That's where it is going to be stored. And we are able to do this because, again, the third parameter here is passed by reference. And any change we do in the function here is going to stick even when the function here has returned, and we're going to have that stored in our third parameter here. And this is a really common technique, especially in code that has to interface with C code out there from C++. And you really need to be aware of this. Now, if we run this program, we're going to see our maximum printed out, and it is going to be stored in our out variable here. Let's do that. We're going to use GCC to build. The build is good. You can clear and run Rooster, and you're going to see that the maximum is 45. If we change and store our maximum in in2 here, and for example, let's make this a 700, and 23. Let's build again to take the changes into account in our rooster.xe binary. We're going to clear and run rooster, and you're going to see that that's the maximum here. We are able to grab whatever is the maximum from these two input parameters and store that in our output parameter here, because we are passing that third guy as a reference. This is really important. We have seen that we can use references to make changes we do in the function stick and be visible in outside variables. But we can also use pointers, and I am going to show you an example of how we can do that. First, we're going to comment this out because we don't want noise output in our program. And we are going to go on top and set up a maxDouble function, which is going to grab our output using pointers. The name of the function is maxDouble. It's not going to return anything, and it is going to take two input parameters, input 1 and input 2, and it is going to tell us whichever of these two is the maximum. The maximum is going to be stored in our output parameter, but we are using pointers to make the changes inside the body of the function stick and be visible on the outside of the function. So we are going to dereference here because the third guy here is a pointer, and we're going to store in whichever is the maximum. And when the function returns, the maximum is going to be visible on the outside. So let's go down and try this out. We're going to say double, out double, and we're going to set up our input here. We're going to say in double 1, and we're going to make this 45.8. Why not? And we're going to do a second input parameter, and int, we should say in, not int. Sorry for this. In double for input double. So we're going to say double 2, and we're going to initialize this with 6.9, for example. We can really put in anything. Now that we have this, we can call our maxDouble function. Let's do that. We're going to say maxDouble. We're going to say in double 1 and in double 2. Let's do that. And we're going to have out double as our output parameter. And because it's a pointer, we need to pass this guy as an address. So we're going to say address of out double here. That's how we're going to be able to manipulate that inside the function here. Once we do this, we are going to have our maximum stored in out double, and we can print that out. So we're going to say stdc out maxDouble, and we're going to say out double std and if we build, why do we have a squiggly line here? We don't have a semicolon at the end of our function called here. So we're going to build with GCC as always. You're going to see that the build is good. We can clear and run rooster. Max is 45.8. If we change and store our maximum and in double 2 here, we can change this guy to 76.9. We're going to build and see that we are actually grabbing the maximum regardless of the variable in which it is stored. If we run rooster, we're going to have our maximum, and this is working exactly as we want. This is really all we set out to do in this lecture, showing you how you can use references to use parameters as output channels for data to get outside of the function and be used in variables that are outside the function here. I really hope this makes sense, and this is a technique you need to be aware of. We're going to see other techniques to do the same thing, and starting in the next lecture, we're going to see how we can return from functions. For now, I hope you found this lecture interesting. We are going to stop here in this one. In the next one, we're going to see how we can use the return mechanism to get data outside our function. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can get data outside of a function through the return mechanism. And this is going to be an alternative to the way we have been doing things in the last lecture, where we used function parameters as channels to get data outside the function. Let's look at a simple example of how this is done. Here we have a simple function called sum. The function is going to return int, and it is going to sum up two parameters that we pass to it, int a and int b. If we get inside the function, we're going to do something really simple. We're going to set up a new variable which is local to the function. We're going to call that result. It's going to be the same type as our input parameters. And we're going to add up a and b and store the result back in our result variable here. Once we have this, we're going to return this for this variable to be visible by whoever called this function here. One thing you should know is that this variable is local to this function here, and it will be destroyed the moment we hit the end of the function here and the function terminates. So if we go in main here, we're going to try and see an example of how we can call this function. We have two variables, a and b, and we have a new result variable set up in the main function. Please note that this variable is very different from the variable we have in the sum function here because they live in different scopes. Okay, we are calling our sum function here and we are passing it two arguments in the form of a and b here. The function is going to compute our sum and it's going to return it, and we're going to store that back in our local variable to the main function here. The result variable here again is local to this main function. Okay, once we call this function, we're going to have our result stored in here, and if we print like we do here, we're going to see it printed out on the console. In this case, it's going to print 50 because 34 adding 16, that's going to be 50. But one thing I want you to know is that this is going to return by value. And what we mean by this is that we're going to copy whatever we return here and store a copy of that in this result variable that we have in the main function. And we're going to prove this. Notice the stdcout statement we have here. This is going to print the address of this local variable. And once the function terminates, we're going to try and print the address of this result variable in the local scope of the main function. And we're going to see two different addresses, and hopefully this is going to prove that we are returning a copy. It's not the original variable that we have in the sum function here that we are returning. Okay, hopefully this drives the point home that we can use the return mechanism to get data outside the function. And we're going to grab the result in our result variable here, and we're going to use it however we want in the main function. But things don't always work like this. Sometimes the compiler is going to insert optimizations and not really return by value. But returning by value is the default. But if the compiler notices that it can do things better, it is going to optimize your returns by value to return by reference. And you're not going to make a copy, but you're going to somehow reuse the local variable in the main function. Let's look at a simple example to really drive this home. We have a function here which is going to add strings. It is going to basically concatenate them using the plus operator here. And you notice that inside the function here, we're going to set up a local variable which is going to store our concatenated string here. And we're going to print the address of the local string. After that, we're going to return the string so that it is usable by whoever called this function. Let's go in main and see how we can use this function here. We are setting up a variable called strResult, which is going to store our result string. We are saying add strings here. We are calling our function, and we are passing in two strings, hello and world. And we want to concatenate these guys. This is going to give us our result, and if we print it out, we're going to get hello world printed out. But the main message here is that the address of the outside string here is going to be the same as the address we have on the inside here. And this is going to mean that the compiler has actually done some magic to return the local variable, because it has seen that we could really be wasting this guy here inside the function. When the function returns, this string result here is going to die off. But the compiler knows that we can reuse that and avoid the work of copying this string, which might be really large. Suppose this string has 1,000 characters inside, and copying it would be a waste. So the compiler is not going to return by value, which is the default. It is going to do some kind of return by reference. But it's really not a return by reference because this is a local variable. We can't really have a reference to a local variable to a function. That would be really bad because we might be able to modify it when the variable is actually dead after the function has returned. So it is some magic that the compiler is doing to save you from unnecessary copies, but you should be aware of this and not make your code rely on returning by value. Okay, now that we know this, we're going to head over to Visual Studio Code and actually play with this. Here we are in our working folder. The current project is returning from functions by value. We're going to grab our template files pretty quick. We're going to copy them. Let's do that. And we're going to put them in the current lecture or project. And we're going to open this guy up in Visual Studio Code pretty quick. Let's do that. Now we have our main CPP file here. We can clean it up a little bit and close the left pane here because we don't need it. The first thing we're going to do is to put in our function, which is going to compute the sum of two integers and return us the sum of these two guys. Inside the function, we're going to set up a result variable, which is going to store the sum, and we're going to return it, and it is going to be visible to whoever has called this function here. Again, I am going to emphasize that this is going to return by value. So what we return is really going to be a copy of this variable here. And we're going to prove that by printing the address of this variable inside and outside the function here. So we're going to set up two variables in main. We're going to say int x. Let's call our input parameters x and y. We're going to put in a 5. And the second guy is going to be a y, and it's going to store a 9. Why not? After that, we're going to set up a variable which is going to store the result. Let's call this result. Why not? And we're going to say sum x and y. Okay, we are passing these guys by value because we don't really care about copying an int. It is a fundamental type. It is really small in memory, so it's going to be very cheap to copy. It's not going to hurt the performance of our application. But what we want to do now is to print the address of the result variable in the main function here and see that it is the same as the address of the variable we have inside here. Another thing you should watch out for is that we are able to get data outside the function here. The sum was a local variable, but we are able to get it out of the function through the return mechanism here. Okay, before we go ahead and run this program, we're going to fix this statement here. We forgot to change this to say out, to mean that it is outside the function here. That's the meaning. We're going to build with GCC. The build is good. We can clear and run Rooster. Now we're going to see that inside the function, the address of the result variable here ends in DAC, and outside the function, when we hit the end of the function here, we're going to see that the address ends in DE4. So this proves that the local variable inside the function and the outside variable here in the main function live in two different memory addresses. They are two different variables, and the return mechanism here is just going to copy whatever we have in the local variable and make it available on the outside here so that we can assign it to the result variable in our main function here. This is how the return mechanism is working, and it is going to be returning by value by default. It is going to be making copies. This is the message here. Now that we know this, I want to show you that there are exceptions to that rule. If you return by value like this, you won't be really always using separate memory addresses for the inside and the outside here. And we're going to prove that with a function that is going to add up two strings. Let's comment what we have out because we don't want this to confuse us. So we're going to bring this inside our block comment here. And we are going to go below our sum function here and set up a new function, which is going to be called add strings. It is going to return a string by value. Okay, it is by value because this return type here is not qualified with anything like a pointer or a reference. So by default, it is going to be by value. And inside, you see we are doing the exact same thing we did in the sum function here. We are adding up two strings. We are storing the result in a local variable, and we are returning that. But if we run this program, you're going to see that the address on the inside is going to be the same as the address on the outside. So let's set up something that we can play with here. We're going to go down in the main function and set up a few variables. We're going to say std string. We're going to say nstr1, and we're going to store in hello. Let's do that. And we're going to say std string nstr2, and we're going to store in world. By now, you know what I am trying to do here. I am trying to say hello world. Okay, once we have this, we're going to set up a result string. So we're going to say std string and say result str, and we're going to say add str, and we're going to add up in str1 and in str2. This is how we do this. And after we do this, we're going to print out the address of the variable here. So let's do that. And it is going to be the address of result str. Let's say that here. And we also need to print the actual result of this operation here. So let's do that. We're going to say stdcout result str. We're going to print the actual string. I don't think we did that on our sum function here, but we can quickly go there and prove that to you. So let's comment this out. Sorry for this. This is going to be confusing, but I don't want to leave you with unexplained things. So we're going to see that if we print this out, we're going to get the sum, which is 14 printed out. Let's do that pretty quick. We're going to go down and say stdcout and say result, and we're going to say result, and we're going to build pretty quick with GCC. And if we clear and run Rooster, we're going to see the result, which is 14 here. And you can change these guys up to really play with us. For example, if we make this 15 and put in a 9, we're going to get a 24 printed out. Let's build again, just to have fun with this. And we're going to clear and run Rooster. We're going to get a 24 here. Now we can comment this back. I am happy. I have showed you this. And we can uncomment our string code here and build and run it. So we're going to build with GCC. The build is good. We can clear and run Rooster. And again, what we want to see is that the compiler is going to optimize this out. It is not going to return by value like we had with the sum function, where we had the address on the inside different from the address on the outside. You see here that inside, we forgot again to change this guy to out. Sorry for this. So we're going to make this guy out, and we're going to build again, and we're going to clear, and run Rooster. Now we're going to see that inside the address ends in D30 and outside the address ends in D30. This can be really confusing because we said we want to return by value. By not decorating our return type with a pointer or a reference or something like that, it is going to be returning by value. And if you return by value, you're going to make copies. And if we made copies, the address on the inside and the address on the outside should be different, but they are the same. The reason is the compiler is going to notice that you are trying to copy strings, and it is going to see that the variable here, which is inside the function, is going to be wasted. When the function returns, by default, this should be really destroyed, and you should copy because you are returning by value. But the compiler is going to insert an optimization to do some magic and make it look like you are returning by reference, and it is really not going to make a copy. So it is going to reuse the address on the inside, and hopefully this is going to prove this to you. The message here is that you shouldn't rely on your functions returning by value, because if the compiler sees that it can do a better job than you, it is going to optimize your return by value to return by reference, and you're going to not be making copies. So don't make your code rely on returning by value and making copies, and you should be aware of these optimizations that the compiler can do behind your back. I would like to welcome you in this new chapter where we will be learning about function overloading. Function overloading is a mechanism we have in C++ to have multiple copies of the same function but taking different parameters. For example, here you see that we have different functions, but all these functions have the same function name. And these are said to be different overloads of the same function. There are a couple of rules you need to be aware of to be able to set up your overloads correctly and get them to work. And that's what we're going to be learning about in detail in this chapter. But now I just want you to see the flexibility you can get with function overloading. For example, here, if we have a few variables in our program, we can call the max function, and the compiler is going to select the most fitting overload in here. So for example, if we call our function with integer argument, the compiler is going to choose this overload here. If we call our function with std string arguments, The compiler is going to choose this overload here, and we don't really need to concern ourselves with making sure we have the correct arguments. The compiler is going to choose the correct function overload for us, and it is going to call it, and it's going to be very flexible to call these functions from our C++ code. This is how function overload can be really useful. We are going to stop here in this lecture. In the next one, we're going to learn about how you can set up function overloads based on different function parameters. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can overload functions based on the parameters that we pass to the function when we are declaring it or defining it. And here is a simple example to drive the point home. Here we have a function called max, and this is the name. It is taking two parameters which are of type int here, and by overloading this function, we will have to use the same name as this function here. So the differences really will be in the parameters that we pass to the function, because the return type isn't involved in defining the signature of the function. So if we try to set up another function called max here, which takes the exact same parameters as our max on top here, the difference is only going to be in the return type. The compiler is not going to allow us to do this because the return type isn't really significant in making two functions different. Okay, the only way we have to set up a function which is legal in C++ is to change something about the parameters that we have here. We can change the types like you see here. For example, we changed the types to be double. If the types are different, we might even change the order of the parameters. You just have to make sure the parameter list is different in one way or another. That's how you're going to get this function to run with the same names here. And if we manage to set up multiple functions with the same name in C++, these functions are going to be called overloads of each other. Okay, if we go down here, we have another overload for the max function. This overload is going to take two parameters, and the parameters are going to be of type string view. They are different from what we have on top here, which is int. So this is a legal overload for this max function here, and we can use it. Okay, we really have a few ways we can make our function overloads by now. We can change the order of the parameter, we can change the number of the parameters, or even we can change the types of the parameters. Again, function overloads are a mechanism we have in C++ to set up multiple functions with the same name to make our code easier to work with. Okay, now that you know that, let's look at a simple example of how we can call our overloads. We have a few variables declared here. We have int variables, we have double variables, and we have std string view variables. And if you go down here, we are calling our max function, passing in integers. So the overload that takes integers for this max function is going to be called here. Down here, we are passing in integer literals. So this is going to call the int overload. Down here, we are calling the function with double parameters or arguments. So this is going to call our double overload for the max function here. And down here, we are passing in our string view parameters. And this is going to call the overload that takes string view parameters. And the last guy here is going to take two string literals. String literals can implicitly convert to std string view. So our std string view overload for the max function here is going to be called. Now that we know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is overloading with different parameters here. We're going to grab our template files like we always do. We're going to put them in place, and we are going to open this guy in Visual Studio Code by dragging and dropping on top of Visual Studio Code here. This is going to open our project here. We're going to click on our main CPP file and open it. We're going to clean it up a little bit and close the left pane here. We are going to go on top here and put in our first max function here. The return type is int in this case. It is going to take two parameters, and it is going to return whichever number is the maximum. And we are taking parameters in by value and returning by value here. Nothing special. We can go in main and call this function, and you already know how to do that. I don't think I really need to do that. But now what we really are interested in is being able to set up different functions with the same function name like we have here. Because if, for example, you take this function and put that down below, we're going to make a copy of it and only change the return type. If we try to compile this program, you see that even Visual Studio Code is unhappy now. If we bring up a terminal, it is going to tell us cannot overload function distinguished by the return type alone. So again, the message is super clear here. The return type is not enough to make two functions different because the return type isn't involved in making the signature unique. What makes the signature unique is either the function name or the parameters that you pass to the function here. So we're going to make this return type bucketable, and we're going to figure out a way to make these two functions different but have the same name here, because sometimes you really want this. One way we have to do this is to change the types of the parameters that we pass in here. So we're going to make them double, and we're going to make them double here, and this is going to be valid C++ code. These two functions are different. Even if they have the same name here, they are two different functions because they take different parameters. So if you try to call this function with integers, this one is going to be called, which takes integers in. If you call it with double arguments, this guy here is going to be called. Let's try and prove this. So we're going to go inside and say stdcout int overload called. I think this is enough. And we're going to go in the double function here and say stdcout double overload called. Okay, once we have this, we also have to change the return type here to double because it's going to make things a little bit consistent here. But now we want to go in our main function here and set up a few variables. We're going to say int x, and we're going to make this a 4, and we're going to say int y, and we're going to make this a 9. Why not? We're going to set up also double variables. Let's say double a and say 5.4 to make it a double variable. And we're going to say double b and put in 7.4. Why not? Now we are going to call max. We're going to say auto result and say max and pass in x and y. What do you think we're going to return here? So what we really are interested in is the return type of the result variable here, and the compiler is going to deduce whatever is returned by this function. If we call the function with x and y are integers, so the compiler is going to search for a function that takes integers, and it's going to find this guy here, and that's what is going to be called. Let's build and run this program. We are not interested in looking at the output here. We're just going to see this std out statements here, print whatever function was called. Okay, we expect the int one to be called, so we're going to see int overload called on the terminal here when we run this program. So let's do that. We're going to build with GCC like we always do. The build is good, so we can clear and run Rooster. We're going to see int overload called. Okay, so this proves that we can set up two functions with the same name and make them different only in the parameters that they take. And the differences may be either in the types of the parameter like we are doing here. They may also be in the order of the parameters. And we're going to see an example of that in a minute. But before we do that, we also need to try this with A and B and show you that the double one is going to be called because we are passing in double arguments here. So let's build again. The build is good. We can clear and run Rooster. This is going to call our double overload. Hopefully this really drives the point home that we can set up multiple overloads for the same function name. And again, the differences are going to be in the parameters that we pass here. We have been able to pass different types for the parameters, and this was legal C++ code. But we can also set up another overload just by changing the types and the order of the parameters. Let's do that. We're going to make the first parameter here int, and once we do that, this is different from any of the overloads we've had. So this is a valid overload for this max function here. This is going to work. We can even change the order of these two guys, and it is also going to be a valid overload. Let's put in another variant of this guy, and we're going to change the first parameter to double and the second one to int. And now we have 4 overloads for the max function. And again, the message here is that you just have to make sure the parameters are different in some way and your overload is going to be valid. And again, I'm not telling you to set up functions like this because in this case, this is really useless, but I am trying to expose this facility to you so that you can use it to your advantage if it makes sense for whatever application you are designing here. So let's go down and put in meaningful output. I think we can come in here and say the parameters that we are passing in here. So we can say int double overload called. And if we go down here, we can take this out and say double int overload called. And to get any of these guys to be called, we have to pass the parameters or the arguments in this order. So if we pass in an int, which is x is an int, and we pass in a double, which is a b here, this is going to call our overload, which takes the first argument to be an integer and the second argument to be double. Let's prove that. We're going to build with the GCC. The build is good, so we can clear and we can run Rooster, and we see int double called because x is an int and b is a double. If we flip these guys, let's say b and x, then we're going to have the overload that takes the first argument of double type and the second argument of int type to be called, and that's this guy here. And we're going to see this message printed out on the terminal here. Let's build with GCC to really prove this. So we're going to do that. The build is good. We can clear and run Rooster and double int overload called. Hopefully you can really see that you can set up all kinds of crazy overloads for your functions. The next thing I want you to see is that we can even change the number of the parameters. For example, here we can set up another guy here and call it max. It is going to be exactly like the one on top here for the first 2 parameters, but let's add a third parameter. Maybe make it an int and say c. And this is going to be a valid overload for the max function here. So we're going to say double int because it takes 3 parameters. I won't go into the details of how we can compute the maximum between these 3 guys. What I really am interested in is showing you that you can set up overloads here. So for this case, we are just going to return, let's just say a. This is going to work. But this is a valid overload for the max function, and it is going to compile. So let's try and do that. We're going to pass in a double, an int, and an int. So we're going to pass in b, which is a double, and x and y. Let's see what is called here. We can compile with GCC. The build is good. We can clear. And please try to come up with what is going to be printed out here. What is going to be printed? Okay, now that you have guessed, we're going to run and we're going to see double int because this is going to call this overload. Again, you can overload based on the differences in the types of the parameters that you pass. You can change the order of the parameters like we are doing here, double int and int double, or you can even change the number of the parameters. Using these techniques, you can make sure that your overloads are different in some way. Before I close this lecture, I'm going to show you that you can also use another overload that takes string view parameters. Let's go down here and put that in. Again, the name of the function is max. The return type isn't really meaningful in making sure 2 functions are different, but watch the parameters we pass here. The types are string view, and we have a and b here, and we are going to compute the maximum. So if we go down here and say max and pass in hello and world, the compiler is going to try and look for a function that takes 2 character array parameters. It's not going to find it because we don't have that guy in here, but it's going to see which function can take something I can come up with through implicit conversions. And the compiler is going to see that it can really convert from a string literal to a string view type. And it is going to insert an implicit conversion from string literal to string view, and this function here is going to be called. So we're going to put in an output statement here. We're going to say string view overload called. And if we try and run this program, let's build with GCC, make sure that the build is good. The bold is good, so we can clear and run Rooster. This is going to show string view overload called. We are able to call this guy here. And again, the message is that we really have a lot of flexibility in how we can set up overloads for a function in C++. And please use this facility to your advantage if this makes things better for whatever application you are designing. I would like to welcome you in this new chapter where we're going to be learning about Lambda functions. Lambda functions are a mechanism we have in C++ to set up anonymous functions. Once we have anonymous functions set up, we can do all kinds of crazy things with them. For example, we can give them names and call them multiple times, or we can even call them directly without even giving them a name. I realize this can be really cryptic, so we're going to head over to the next lecture and see how we can declare and use our Lambda functions. Go ahead and finish up here and meet me there. In this lecture, we're going to see how we can declare and use our Lambda functions. And again, Lambda functions are a mechanism we have in C++ to set up anonymous functions. And an anonymous function is a function without a name. We're going to see how we can set up an anonymous function, optionally give it a name and call it, or we can even call it directly without giving that a name. Let's see how we can do that. Before we talk about anything about Lambda functions, we're going to first see the Lambda function signature. And there is a special syntax you have to follow if you want to set up a Lambda function in C++. The first thing you have to put in place is angle brackets like this, and that's going to be your capture list. We are not going to talk any more about this. We're going to have a chance to talk about this in detail. After your capture list, which is going to live in this pair of angle brackets, you're going to have the parameters to your Lambda functions. And this is where you can pass arguments if you want to call your Lambda function. After that, you're going to have a return type for your Lambda function, but you don't have to put this in explicitly. You can leave this out and the compiler is going to deduce your return type by itself. After all these things, you have to put in a pair of curly braces, and inside these curly braces, we're going to have our function body, and we can do whatever we want our Lambda function to do in this function body here. After this, you will have to remember to put your semicolon to make whatever statements contain this Lambda function to be valid, and this is the syntax you have to follow. Here we have a simple example. So we have our Lambda function. We want to say hello to the console. This is what we have in the body of the Lambda function. But notice that we have our capture list, which is going to be delimited by these angle brackets. We have our parameter list, which is going to be empty in this moment because this Lambda function doesn't take any parameter. And we have our body, which is going to live within these two curly braces. And after that, we have our semicolon to make this a valid C++ statement. If we try and put this thing in our C++ source code, this is going to be a valid Lambda function. But it isn't really useful by now because we can't call it. One way we have to call it is to give it a name. And we can give it a name by assigning our Lambda function to a variable like we see here. Once we have our Lambda function declared like this entire thing is going to be our Lambda function type. We can take this and assign that to a variable which is going to deduce the type using auto type deduction here. This is what we are doing. Once this thing has a name, then we can call it with the syntax we have here. And if we run this code now, it is going to print hello world to the console. I realize this syntax can be really cryptic, but if you try to remember this, you're going to find that Lambda functions are really cool. And later in the course, we will see that they really make a lot of things easier in C++. So try to remember the syntax here, and everything is going to flow from here. Again, the syntax is to have the capture list, which is going to be the first thing. The second thing is going to be the parameters. The third thing is going to be the return type, which is optional. You can leave this out and the compiler is going to deduce this. And after this, you're going to have your pair of curly braces, and the body of our Lambda function is going to live within these curly braces. This is the syntax you need to remember. Okay, we have seen that we can give a name to our Lambda function and call it, But it is also possible to call our lambda function directly without giving it a name. And we do that by appending a pair of curly braces to the lambda function definition here. So we have a lambda function, we have our curly braces in, we have our parameter list, we have our body here, and after the closing curly brace, we're going to add a pair of parentheses to call this lambda function. And because this lambda function takes no parameter, we're not going to put any argument within our parentheses here, and this is going to call our lambda function. Don't worry if you find this confusing. We're going to head over to Visual Studio Code in a minute, and all of this is going to make sense. Okay, so far we haven't really seen that we can pass parameters to our lambda function. Here is a simple example that takes parameters. This is a lambda function because it follows the syntax for lambda functions. We have our capture list, we have our parameter list, we have our curly braces, and the body is going to live inside these guys, and we are calling this lambda function directly with this parameter list. The lambda function is going to take two parameters of double type. We're going to print out the sum of these two numbers, and we are going to call this lambda function directly. Notice that we are passing in our arguments as double literals. Okay, this is how you can set up a lambda function that takes parameters and call it directly. Another thing we can do is make our lambda function return something. And that's really simple. We're going to set up the lambda function like this. So it's going to take two parameters, a and b. And here you see that we are returning a plus b. And we can do that. The lambda function is now going to return something. And this entire thing we have here is going to be a lambda expression. The lambda function is going to be called, it is going to return something, and what the lambda function returns is going to be assigned to this result variable here. And if we print it, we're going to get the sum of whatever we pass in here printed out on the console, and we're going to see it printed out on the terminal. It is also possible to put your lambda function directly in an output statement. I realize this can be really confusing, but please look at this entire lambda function thing here as a single value. Because this is a lambda function that is going to return something, and what is returned by this lambda function is going to be printed as our result here. Again, I realize this may be confusing to many of you guys. We are going to head over to Visual Studio Code in a minute, and we're going to see this, and you're going to really understand. Okay, the last thing we're going to look at is that we can specify a return type to our lambda function. And the syntax to do this is to do a dash, a greater than symbol, and put your type after that. And when you do that, now this lambda function is going to be forced to return double type. Even if you pass it two parameters that are not of double type, we are going to add them up, and the return type is going to be implicitly converted to double, and that's what we're going to return, and we can print it out on the console. And we're going to see an example of this in a minute when we hit Visual Studio Code. In fact, this is really all I had to share with you in the slides. I realize many of these things may be confusing. We are going to head over to Visual Studio Code and play with these things step by step, and I am sure you're going to understand. Here we are in our working directory. The current project is declaring and using lambda functions. We're going to grab our template files and put them in place. Let's do that. And we're going to grab our folder here and drag and drop it in Visual Studio Code. And this is going to open it. It is opened here. We have our main CPP file opened. We can close the left pane here because we don't want it anymore. And we can clean up our function here. And the first thing we're going to do is to put in the syntax for a lambda function here and use it as a reference as we learn about this. I think this is going to make things a little easier. So the first thing we want to do is to declare a lambda function. And the first thing we need to put in is a capture list. A capture list is going to be englobed in these angle brackets. So this is our empty capture list. And after this, we're going to put in a parameter list, which is going to live inside these parentheses here. After that, we're going to put in an optional return type. For now, we're going to ignore this. And after that, we're going to put in our pair of curly braces. And inside this pair of curly braces is where the body of our lambda function is going to live. So inside here, we can do whatever we want in the body of this lambda function. For example, we can say hello world, which is the logical thing to do at this point. So we're going to say hello world here, and we're going to put in our new line character with ENDL. Okay, now we have a lambda function declared, but we have to put in a closing semicolon because this is a C++ statement. Okay, now we have our lambda function declared, and this is valid C++ code. If we try to compile this program, you're going to see that it is going to compile fine. Okay, build finished successfully. And if we try to run it, it is not going to do a thing because we are declaring the lambda function here, but we're not calling it to get it to do things. So let's bring up a terminal and show you that if we run this program, it is not going to do anything. So let's do clear and run Rooster. You're going to see that it's not going to print anything. And we can even go down here and put in a closing stdc out statement saying done to mean that we are hitting the end of the function here without doing anything. So if we build again, the build is going to be good. We can clear and we're going to run Rooster. You see, we are printing done. We are hitting the end of the function here, and we're not seeing hello world. So this function here, or this lambda function here to be exact, is not being called. One way we have to call it is to give it a name. And we have seen that to give it a name, we have to